Hello and welcome to you all here today from around the world for the SchillerInstitute symposium titled The Physical Economy of the Noosphere, Reviving the Heritage of Vladimir Vernadsky. This conference is carried out as a reassertion of the practice of independent free inquiry into science and a celebration of the human creative process. It's also intended to provoke a discussion for the need for a new world strategic and development architecture at a level far above and therefore liberated from the failed, addictive, ideological constraints that have launched the world on a path of self-destruction from which we must rapidly retreat. It was Vladimir Vernadsky who was the creator of a higher, rigorous, dynamic conception of what has come to be called in the last 80 or so years by the name ecology. Vernadsky's is an anti-Malthusian conception, not a limits to growth construct. Today's first panel is titled Vernadsky's Revolution in Science and Thought, and what we will call the revolutionary changes in the way that we think about things. This is a phrase taken from the man whom you're about to see in our actual introduction to today's symposium. And that is being given by the late physical economist and co-founder of Executive Intelligence Review magazine and co-founder of SchillerInstitute, Lyndon LaRouche. LaRouche, who was aware of the work of Vernadsky as early as in the 1940s, acquainted a generation of young Americans and others with Vernadsky starting in the 1970s, and then 25 years later and 20 years ago, built a science team out of another generation of young people from all over the world. They, working with LaRouche and a few members of that earlier generation over the last 2 decades, have done translations and investigations of Vernadsky's work. These have been published in the 21st Century Science and Technology magazine, and then in 2013, on the occasion of the 150th anniversary of Vernadsky's birth, it was a 2-volume special edition featuring translations of Vernadsky's work, which was published. 2 of today's speakers on our first panel were directly involved in that project. Essays by Lyndon LaRouche on Vernadsky appeared throughout this period, with titles such as LaRouche on Vernadsky and the Future of Brazil's Agriculture and Vernadsky and Dirichlet's Principle. Some of these essays were collected into book form, as in The Economics of the Noosphere and Earth's Next 50 Years. We want to begin today by allowing you to experience a proposed revolutionary change in how nations can come to think about the most practical matters of manufacturing, transportation, and trade, viewed from the standpoint of Lyndon LaRouche's dialogue not only with Vernadsky, but with Russian thinkers of 20 years ago. The excerpt that we're going to see is taken from a conference that happened in Germany in May of 2001. And LaRouche on this occasion shared the podium with economists Sergei Glaziev and Stanislav Menshikov. Mr. Glaziev was the author of the book Genocide, Russia and the New World Order, and Mr. Menshikov authored the book The Anatomy of Russian Capitalism. Lyndon LaRouche contributed an introduction to each of these works. Here in this excerpt, Lyndon LaRouche demonstrates what is meant by the idea, the physical economy of the noosphere.
As has been understood for more than a century, almost a century and a half now, the only way this could be worked was to develop a system of infrastructural development which would effectively link the Atlantic Ocean to the Pacific Ocean across Eurasia. Now, this is not railroads. This is not Silk Roads. These are corridors of development, corridors which run a range of, say, 100 kilometers in width, up to 100 kilometers, from the Atlantic to the Pacific, going in various directions, north, south, and so forth. Along these routes, as we did in the United States with the Transcontinental Railroad, that the area on either side of the transportation axis becomes immediately in and of itself a sustainable area of economic development. Then by that means you can branch out from the main corridors into subsidiary corridors of development and capture the area. Therefore, if we conquer this area, what happens? Take a transportation alone. People will think today, who don't think, will think that ocean freight is the cheapest way to move freight. It's not true. The cheapest way to move freight is across land, not by truck. Trucks running up and down the highway tell you that the economy is being mismanaged. Too many trucks. It's not efficient. Costs too much. Intrinsically bad. Railways are much better. Integrated transport systems featuring railways, especially magnetic levitation systems, are excellent. Magnetic levitation systems move passengers more rapidly, but magnetic levitation systems for moving cargo, for freight, that is really a wonder. That's where the payoff comes. If you can move freight from Rotterdam to Tokyo at an average rate of 300 kilometers per hour without much stopping along the way, and if for every 100 kilometers of motion across that route you are generating the creation of wealth through production as a result of the existence of that corridor, then the cost of moving freight from Rotterdam to Tokyo is less than zero and can be up to 200 to 300 kilometers per hour. Now, what ocean freight system can do that? Did you ever see a large supercargo ship producing wealth while it was traveling across the ocean? And at what speed? So therefore, we've come to a turning point in technology, which have emerged over recent periods, where the development of the internal landmass of the world and the great typical frontier is Central and North Asia. It's the greatest opportunity, single opportunity, before all mankind for development. Now, this requires some revolutionary changes in the way we think about things. This means that we would be engaged in the greatest change in the environment in the history of mankind. This single project, say a 25-year or more, development of Central and North Asia in this direction, including the conquest of the tundra. The Arctic tundra is one of the great frontiers to be mastered. It can be done. Would mean a great change in the environment. Now, how are we going to decide what is good and bad about changing the environment? Well, what people think today about the environment is pretty stupid. It's wrong. It doesn't make any sense. They don't know what they're talking about. And you see the kind of education you get, no wonder they believe that nonsense. Especially people with physics degrees who don't know which end is up. But the great theory of the environment was established by a Russian of Ukrainian credentials, Vladimir Vernadsky, with his concept of geobiochemistry. See, what you're taught, the problem here is you're taught in most universities and elsewhere about science is nonsense. It's a damn lie, most of it, to put it frankly. What you're taught as basic physics is mostly a lie. Because we know from, as Vernadsky demonstrated this in his own way, and others have known it and shown it, that there are actually three principles involved in man's physical relationship to the earth and the universe. Three categories. One, the category we call non-living processes. What most people who aren't well educated call physical processes. Yeah? The second one, which some people don't understand, those in molecular biology, they refuse to understand it. It's called the principle of life. You will never get life out of a non-living process. Life is, as Pasteur insisted, is a principle unto itself. but how it's a universal physical principle, which, as Vernadsky demonstrated with his biogeochemistry, is that the history of Earth is what? The oceans and the atmosphere were produced by living processes. Down several kilometers in the Earth's surface, most of the Earth that we're in touch with as humanity was created as a byproduct of living processes. What Vernadsky calls the natural products of the biosphere. We can measure it. We can measure the power of the biosphere over the non-living process. We can measure it. Living processes are superior to non-living processes. They're more powerful. They're apparently weak, but their long-term effects are more powerful than the short-term effects of the non-living processes. Now, there's a third thing, which, again, Kant won't let you know. Immanuel Kant. That's why they call him Kant, because he can't do anything. If you believe him, you can't do anything either. The essential nature of man is that we are capable of making discoveries of universal physical principle. Discoveries we can validate in known experimental ways. By applying these principles, we increase our power in the universe in ways that can be measured physically per capita and per square kilometer. We can measure this in terms of the demographic effect of this kind of action. That is, does the human species improve its life expectancy, its power to exist in the universe as a result of this? Yes, it does. That's good. Mankind actually is primary mastery of nature has occurred in terms of man's mastery and development of the biosphere. So actually, the biosphere is including what we call basic economic infrastructure, such as waterways, power systems, transportation systems. These are the development of cities, of good cities at least. These are natural products of cognition which are reflected as improvements in the biosphere. The biosphere is weak. It is stupid. It does not know how to deal with the deserts it has. It does not know how to deal with the tundras. It does not know how to deal with other problems that it has. But we as human beings can come to our poor, stupid slave, the biosphere, and say, we will educate you and we will make you stronger and better. So mankind intervenes in the biosphere to make the biosphere better. And so the principles of discovery, the application or discovery of principles applied to the environment creates the natural products of cognition in the biosphere, which improves the biosphere, which increases the potential for human life. So this is not a mysterious, arbitrary area. This is an area of science. It's an area of scientific precision, which would mean that the job to do is not to say, is it good or bad to tamper with the environment? It's very good to tamper with the environment if you know what you're doing. But you have to develop the science of water management, the science of transportation, the science of reforestation, the science of how to change and control the atmosphere and the climate. You can't make big mistakes. These mistakes will live with you for a quarter century or longer. You can't make big mistakes. Therefore, you have to have competent people, competent groups of people making the determination of how we do this. But by changing the biosphere of Central and North Asia, and changing the biosphere in the arid areas of China and so forth, we will create the greatest boon for humanity in any part of this planet. What we need is a task-oriented mission task force to undertake the policy planning for precisely this, and it must be international.
If you've just joined us, we want to welcome you to today's SchillerInstitute Symposium, The Physical Economy of the Noosphere, Reviving the Heritage of Vladimir Vernadsky. This is our first panel, whose title is Vernadsky's Revolution in Science and Thought. You have just heard the late physical economist Lyndon LaRouche, founder of Executive Intelligence Review and co-founder of the Schiller Institute, present 21 years ago the vision of what should have been the form of economic cooperation between East and West. Our first speaker today is Bill Jones. He is Washington correspondent for Executive EIR News Service, Executive Intelligence Review News Service, and his topic is Vernadsky's Promethean concept of scientific thought as a geological force. Good morning, Bill.
Good morning, Dennis. Thank you very much. I must say it's a pleasure and honor to be here today with such an eminent group of people to discuss the heritage and the implications of the work of Vladimir Vernadsky. It's of the utmost importance in this particular period as we begin to revive the heritage of the great Russian-Ukrainian scientist Vladimir Ivanovich Vernadsky at a time when certain forces here in the West, anxious to maintain control over a bankrupt financial system, are preparing to divide the world into two warring parties, even at the risk of causing nuclear war. It is also important to note the work of this proudly Russian scientist with deep Ukrainian roots in order to underline the fact that these two nations and these two peoples have been united culturally and in other ways in a very complex relationship for over 1,000 years and more. In the present climate of cancel Russian culture, Ukrainians are in danger of losing an important element in their cultural heritage, including the pioneering work of Vladimir Vernadsky, who helped to found the Ukrainian Academy of Sciences at the end of the First World War, often over the objections of those who desired a total Ukrainianization of the process. The name of Vernadsky is not unknown in the United States, particularly in scientific layers, but little is known of the real nature of his thought. A limited number of writings of Vernadsky were introduced into the US by people who had a diametrically opposed view to his conception of man and man's role in the world. For most people, Vernadsky is simply viewed as some kind of early environmentalist. While some of Vernadsky's writings had been published in the US prior to his death in 1945, including an important testament of sorts in the January 1945 issue of Scientific American, it was not until 1970, with the publication of an issue of Scientific American dedicated to the biosphere, that Vernadsky's name again appeared prominently in American publications. The publication of this particular issue of Scientific American was the clarion call for the creation of the Malthusian environmentalist movement of the 1970s. In that sense, Vernadsky was introduced, in that issue, Vernadsky was introduced to the American public by one G. Evelyn Hutchinson, a British ecologist teaching at Yale, who later became one of the founders of the 1970s zero growth movement. In 1947, Hutchison had written an article entitled On Living in the Biosphere. In it, he wrote, "The population of the world is increasing, its available resources are dwindling, apart from the ordinary biological processes involved in producing population saturation, already known to Malthus. The current disharmony is accentuated by the medical sciences, which have decreased death rates without altering birth rates, and by modern wars, which one may suspect put greater drains on resources than on population. Terrible as these conclusions must appear, they have to be faced." So much for Hutchinson. Now let's hear Vernadsky's views on Malthus's predictions. Malthus doesn't realize that this fundamental results lead to entirely different conclusions. You might say that they're simply not true because he did not take into consideration the fact that estimating accurately the long-term growth of human population geologically as regards food and the necessities of life, the expansion of plant and animals comprising it, must inevitably increase with greater force and speed, expressing a more rapid rate of reproduction than that of the population. It is necessary to always have this correction in mind. Historically, it is only the irrational elements in our social system that make it difficult to clearly observe the effect of this natural phenomenon. So why was the Malthusian Hutchinson the one to present Vernadsky to the English-speaking world? No doubt it was his friendship with Vernadsky's son, George, who was together with him at Yale University, George, a professor of history, and he working in the area of ecology. Hutchinson had also helped George have a couple of Vernadsky's works on biogeochemistry translated or published in English, which George himself had translated in US academic journals. Later, when Vernadsky's early study entitled The Biosphere, which concentrated on his revolutionary views on the role of living matter in transforming the inert matter of the earth, it was soon lauded as a Bible of the early environmentalists. In fact, the real Vernadsky was not revealed to the English-speaking world until his real view of man in the universe, until the seminars of Mr. LaRouche in the 80s, 90s, and 2000s. While LaRouche had some knowledge of Vernadsky during the period of intense studies after his service in the CBI theater during World War II, it really was not until the 1970s that he began to understand the depth of the man's thinking and began to understand this notion of Vernadsky's idea of the noosphere, which was a term Vernadsky used to describe the era in which scientific thought begins to take the dominant role in shaping the biosphere, as Mr. LaRouche had indicated. In his own unique contributions to physical economy, LaRouche had pointed to the scientific discovery and its implementation in the form of technological innovations in the economy as the central factor in economic production, which allowed mankind to reproduce itself at ever higher levels, which is wholly consistent with Vernadsky's views, as Vernadsky's views were indicated in his quote on Malthus. For LaRouche, continued economic development was wholly contingent on these discoveries, allowing man to leapfrog, as it were, to higher stages of development. Over the many thousands of years of human development, this was characterized in energy by ever more dense forms of energy, from sunlight to fire to coal to oil and to nuclear power. Increasing energy flux density, as LaRouche called it, was a fundamental characteristic of the progress of man and the strongest argument against the modern day Malthusians and their limits to growth. Vernadsky's view dovetailed completely with this concept. Vernadsky received his education at St. Petersburg University with teachers like the great chemist Dmitry Mendeleev, who developed the periodic table, and Vasily Dokhachev, who's known as the father of soil sciences. The sciences were not only being taught, they were actually in the process of being developed. So this was a tremendous ferment going on at that time in Russian science. During his career, Vernadsky would make major breakthroughs in such fields as crystallography, mineralogy, hydrology, and geochemistry, as well as writing extensively about the history of science and the history of Russian science. He can well be considered the founder of the science of biogeochemistry. He was the first, in fact, he was the first in the world to have a biogeochemical laboratory, which began investigating along the lines that he had pointed out. In 1910, Vernadsky was convinced that the world was entering the age of atomic energy. And in 1911, he organized an expedition to search for radioactive ores in the Russian Empire. In 1921, he established the Radium Institute in St. Petersburg. While working in Ukraine in the chaotic situation following the First World War, where the so-called Allies were working to dismantle both Germany and the toppling Russian Empire, Vernadsky, after a long period of illness with typhoid, made his first major breakthrough. This was the discovery that life, or what he termed more concisely living matter, far from being simply a phenomena distinct from non-living matter, and even less a byproduct of non-living matter, a thesis which he totally rejected, represented an independent and powerful force which in fact on the atomic level interacted and transformed the inert matter it came into contact with. And the rapidity with which life reproduced itself, even in areas in which it previously had not existed, indicated to Vernadsky that the biosphere, the realm of life, was one of the most important forces on Earth. Indeed, perhaps even in the galaxy. In addition, Vernadsky believed that living matter only came from living matter, contradicting the then predominant theory of abiogenesis, the idea that life proceeds from non-life. Furthermore, Vernadsky was very much taken by the discovery of Louis Pasteur of chirality in living matter, whereas in chirality is the disymmetry in living matter, which you do not find in non-living matter. Working in the 1920s for several years with Marie Curie at the Curie Institute in Paris, Vernadsky also acquired an interest in a study that was being done, that had been done by the then deceased husband of Marie Curie, Pierre Curie, concerning the nature of this disymmetry or chirality that Pasteur had found in living matter. Curie began working on this in the last years of his life before his untimely death in a car accident, and characterized the phenomenon more specifically as a different state of space than that of non-living matter. This indicated to Vernadsky that the geometry of Euclid was wholly unsuited to explain this type of phenomenon. And he began to confer with Russian mathematicians regarding the possibility of using some form of Riemannian geometry to explain or to as a framework for this type of phenomena. This was another issue that sparked the interest of LaRouche, who also in economics, in his own view of economics, emphasizing the leaps of technology, the discontinuities, you might say, also drew the conclusions that this required a Riemannian framework in order to understand it fully. During his visits to Russia in the 1990s, in one hand, as a type of track two discussion on behalf of the Clinton administration, and then in the 2000s, on the invitation of Russian colleagues, this became one of the topics, this issue of the disymmetry and the need for following up in the study of these alternative states of space in the lectures he gave on Vernadsky and economics. In 2001, he authored the book, The Economics of the Noosphere, which elucidated his thinking on these matters. But what was Vernadsky's sense of the noosphere? In contrast to the French Jesuit Teilhard de Chardin, who used this concept in a theological sense, Vernadsky's notion was entirely this worldly. As Vernadsky saw it over the last 5 centuries, from the age of exploration to the modern age, the 20th century, mankind had, like life, extended his reach over the entire globe. Through technological progress based on the creative processes of the mind, he had transformed the world around him, increasing the flux of energy in the biosphere, making it more productive. And as with the legend of Prometheus, where Prometheus stole fire from the gods and was chained to a rock for all eternity, the real story is probably much different, but is also extremely significant. As Vernadsky explained the notion of the discovery of fire in a dissertation in 1938 entitled Scientific Thought as a Planetary Phenomena, he says, "It seems as if Homo sapiens, or as close as predecessors, appeared not long before the onset of that glacial period, or in one of its warmer episodes. Man survived the severe cold of that period, possibly due to the great discovery that had been made in the Paleolithic age, the mastery of fire. That discovery was made in 1, 2, or possibly more places, and slowly spread among the peoples of the earth, it seems that we're dealing here with a general process of great discoveries in which it is not the mass action of mankind smoothing over and refining the details, but rather the expression of separate human individuals. As we'll later see, we can track this phenomenon more closely in very many cases nearer to our own era. The discovery of fire presents the first instance in which a living organism takes possession of and masters one of the forces of nature. Undoubtedly, Vernadsky continues, this discovery lies, as we now see, at the foundation of mankind's subsequent future increase and of our present powers. Later, Vernadsky would add another phrase, the action of that force, scientific thought, exerts a profound and powerful influence on the course of the Earth's energetic phenomena, and consequently must undoubtedly have reverberations, albeit less powerful, beyond the Earth's crust, in the existence of the planet itself. That force is the intellect of man, directed and organized through the volition of man in his social existence. Vernadsky saw this development as a new and higher phase in the development of the biosphere, where the mind of man, or scientific thought itself, becomes a geological force. Indeed, the predominant geological force in the biosphere. By the time of Vernadsky, that force had already reached the lower limits of the stratosphere in the development of the airplane and aerostatic devices, and had penetrated to the lower granite levels of the Earth. And knowing the works of Konstantin Tsiolkovsky, one of the early space pioneers, whom Vernadsky characterized as a new Columbus, he foresaw that man would soon be going into cosmic space. If he did not find life elsewhere in the cosmos, which Vernadsky firmly believed he would nevertheless bring the biosphere with him, expanding the biosphere by means of the noosphere. The vision of Vernadsky is not an isolated pipe dream, but represents, as he characterized it, an elemental natural force. But since it takes place in the noosphere and is not merely the blind action of the biosphere, it is dependent on the creative action of man to bring it to realization. But the preconditions are already here for man to begin realizing a world in which those old elements that have been plaguing us for so long, namely poverty and disease, can be ultimately overcome. As Vernadsky stated in his last unfinished and untranslated work, The Chemical Structure of the Biosphere and Its Surroundings, he said, is becoming clear and is entering into man's consciousness that we now have before us the real possibility where we need no longer tolerate malnutrition and famine, poverty, or weakened physical conditions, making people unable to withstand disease, and can expand to the maximum degree human life. But the battle for realizing this new future for humanity is far from over and will continue perhaps for some generations, but it inevitably is coming to light as an elemental process in the realization of the noosphere. These words were written in the 1940s with a view that the world would end with the victory of the Allies. Almost 2 generations have passed since these words were written. Now a new generation is faced with a situation in which mankind stands on the edge of a precipice, facing again, as in the early 1960s, the danger of a conflict between nuclear powers. To avert that danger, the world must turn to the view of Vernadsky and bring our nations together to realize the common aims of mankind. As Lyndon LaRouche urged his Russian colleagues during his visit to Moscow, in the ideas associated with Vernadsky's conception of biosphere and noosphere will provide a needed added guidance for new global forms of cooperation among sovereign commonwealths. We must move in that direction with all due speed, and it is hoped that making the world more acquainted with the work of this great Russian scientist will help us to move in that direction. Thank you.
Thank you, Bill. And if you've just joined us, welcome to today's Schiller Institute Symposium, The Physical Economy of the Noosphere, Reviving the Heritage of Vladimir Vernadsky. This is our first panel titled Vladimir Vernadsky's Revolution in Science and Thought. You've just heard Bill Jones, Washington correspondent for EIR News Service. Our next speaker is Dr. Vladimir Voykov, Doctor of Biological Sciences at the Mikhail Vasilyevich Lomonosov Moscow State University. His topic is Vernadsky's concept of living substance, with emphasis on the fundamental role of water in its existence and development.
Dear colleagues, it is my great pleasure and honor for me to participate in this remarkable meeting devoted to the reviving the name, ideas, heritage, and mission of the great Russian-Ukrainian scientist Vladimir Ivanovich Vernadsky. I am very thankful to Mr. William Jones for the invitation to present a talk here. I got acquainted with Vernadsky's works many decades ago when I was postgraduate student at the Faculty of Biology at Moscow University. From this reading, I understood that biology of that time, and even modern biology, nearly completely ignores Vernadsky's teaching about living substance as the primordial entity, the engine of the development of the universe. Since that time, I worked on many projects, but I continue to keep in mind Vernadsky's assertion that something is wrong with scientific cognition of living matter. Only about 2 decades ago, I began to realize that water is the mother of all life, as Albert St. Georgi insisted, while biology practically ignored this. I remembered that Vernadsky also assigned water a central role in the biosphere, so I suspected that real, natural water may be the essence of animated state of matter, and that the fast developing research in water science may help to promote further Vernadsky's teaching of living matter. That is why, in the message that I suggest to your attention, I'll try to synthesize Vernadsky's concept of living substance and modern ideas about the functional role of water in life. I entitled my presentation Vernadsky's concept of living substance, with the emphasis on the fundamental role of water in its existence, properties, and development. Living matter was very important notion for Vernadsky. In 1920, he wrote in his diary, "I began to realize clearly that I was destined to tell humanity something new about the living matter, and that this is my vocation, my duty, which I must carry out as a prophet who feels a voice within himself calling him to action." In 1922, he wrote a small brochure which he entitled "The Beginning and Eternity of Life." And in this brochure, he was talking about most important questions for biology and for universe in general. Cosmos is unthinkable without matter, energy, and space, he wrote. But can it exist as we know it without life? And he named thinkable mechanisms of the emergence of life, which were discussed at that time. Abiogenesis or archaeogenesis, that all living things originated from dead matter. Heterogenesis, that all living things originated both from inorganic dead matter and remnants of living things. But he insisted that these were just hypotheses that has never been proved. Probably they are right, probably they are wrong, but what we knew for sure by that time, and such facts, great facts he called empirical generalization, that all living beings come from living beings, which is called biogenesis. And he reminded that it was the Italian naturalist Francesco Redi who in 17th century proclaimed omni vivum ex viva. Studying this problem, he came to several empirical generalization for living matter or living substance. Life did not originate from stagnant inert matter. Second, there have never been lifeless epochs on the planet. Third, the current living matter is connected with the previous one, so all life is unified in its basic properties. Its chemical effect on the environment has always been the same. There were no big changes in the quantity rather than quality of living matter, and therefore in the number of atoms captured by it. And living matter works on solar energy chiefly. And I stressed here the word chiefly. That means that living matter may work not only on solar energy. We used already a couple of terms, living matter and living substance. And what is the difference between these two terms? I translated the Russian term «живая материя» into living as living matter in some cases and living substance in other cases. So here is the citation of Vernadsky. I will call living matter the totality of living organism expressed in weight, in chemical composition, in measures of energy, and in nature of space, special geometry. Living matter is more or less continuously distributed on Earth's surface. It forms a thin but continuous cover on it, in which free chemical energy generated by it from the energy of sun that it concentrates. And this layer of the Earth's shell is called, he calls, biosphere. It represents one of the most characteristic features of organization of our planet. So this is a definition of living matter, which I'll use further on. But what is living substance? Living substance is a special form of being of chemical elements, which or animated matter, of which all living organisms are constituted in biosphere. What are the special properties of living substance? And he asked this question in the this brochure, The Beginning and Eternity of Life. He said there that there is some fundamental difference between the living substance, animated matter, and the dead matter. And this difference should be due to some kind of difference of matter and or energy in a living organism compared with those forms of matter that are studied in physics and chemistry, that is ordinary, inert, stagnant, lifeless matter. It also indicates that insufficiency of our usual ideas about matter and energy derived from the study of stagnant nature to explain all the processes of life. What Vernadsky emphasized already in 1920s and 1930s, that from the point of view of our usual physical representations, this animated matter would have the property and character of not only conventional matter, but also of energy. And now I would like to shift from discussion about Vladimir Vernadsky to his contemporary, also great scientist to my mind, Erwin Simonovich Bauer, who also worked in 1920s, 1930s in Soviet Russia. He wanted to understand what the living state of matter represents, and go into much more details than Vladimir Vernadsky. In his book, Theoretical Biology, which was published in Leningrad and Moscow in 1935, he suggested the general theory of living substance, which was based on a few, in fact, three principles or axioms, as he called them. Or using the terminology of Vernadsky, empirical generalization. First principle, the principle of stable non-equilibrium, tell us what is the essence of living systems. According to these principles, all and only living systems are never at equilibrium. At the expense of their free energy, that is energy that can be used for the performance of work, they ceaselessly perform work against equilibrium demanded by the physical and chemical laws appropriate to the actual external conditions. In other, more simple words, living systems, unlike inanimate things, persistently perform work to stay alive. In fact, what is the essence of the matter in living systems which performs this work? And this is the second principle formulated by Bauer. According to him, stable, non-equilibrium or excited state is displayed at all levels of the living system organization, including the molecular one. Better to say now, from molecular one to biospheric, or probably the level of the universe. But we return back to the to molecular and cellular level. Bauer states that structure of matter in an excited state differs from structure of the same matter in the equilibrium, ground states. According to him, all the work performed by a living system is produced at the expense of structural energy, energy of the excited structural elements of the system. I remind you that it was written in 1935, but it is talking about the laser state of living matter. Living matter is continuously pumped by energy, and when the structural energy is released, it is free energy which is capable to perform work. Unfortunately, I do not have time to go deeper into the Bauer's theory of living state. But I would like to remind you that Bauer managed to deduce from his basic principles all manifestations of the living state, including metabolism, growth and development, reproduction, excitability, ability to perform external work, aging and apoptosis, and cellular complexity. However, Bauer did not and could not specify the nature of living matter able to persist in a stable, non-equilibrium state. Neither he suggested a convincing mechanism of conversion of low-grade chemical energy of food into high-grade structural energy, energy of excitation of living matter. But when we're talking about real living matter, or real, better to say now, returning to this term, living substance, that what is the major chemical constituent of living substance? Now we return back to Vernadsky. He, in the history of natural waters, he wrote that water occupies a unique place in the history of our planet. There is no natural body that could compare with it in its influence in the cause of main geological processes. All natural substances, minerals, rocks, living bodies are permeated and covered by it due to its properties. It is omnipresent in the upper part of the planet and also in its deepest part. And I would like to add now that water is omnipresent in the universe. During the last 10-15 years, it was demonstrated that water is the third by abundance substance in the universe after helium and hydrogen. And it plays an exceptional role in the phenomena of life, according to Bauer, according to Vernadsky. At least 2/3 by weight of all living matter of the planet, of all organisms, consist of living liquid water. For many aquatic organisms, it is more than 90 9.5% by weight. And Bauer reminds that French biologist Dubois-Reymond correctly said, life is animate water, animé. Here is just example of living water. There are some jellyfishes which consist by weight on 99.9% of water, and all this bioorganic matter which we so carefully study constitute only 0.1% of water. And this living water lives in what is supposed to be much less living, or if you want, inanimate water, seawater, which is much more dirty than water which constitutes the body of a jellyfish. Contrary to the general accepted view that water is in equilibrium with the environment, unless it is affected by the external force, natural waters are never in equilibrium. They permanently reside in the far from equilibrium state, the state of stable non-equilibrium, if to use terminology of Erwin Bauer. Due to this property, waters are capable to self-organization and may solve the source of high-density energy. And we know this. We've seen it very often, that self-organized water, for example, self-organized water in tornadoes, by the way, clouds are also self-organized water, is the source of maybe stronger than the steel. Though this is not solid water, this is a special form of dynamic water, water as a process. Atmospheric water is the source of electricity, and Vernadsky also emphasized that water may be the source of tremendous quantity of electricity. Now, water itself is a fuel. It may burn. First, it was discovered 220 years ago, but then forgotten. Then it was rediscovered by the end of the 19th century, and it was again forgotten. And already now in the 21st century, it was demonstrated by American inventor John Canzius and proved by Professor Rustom Roy from Pennsylvania University that salted seawater may burn under irradiation of radio waves, and temperature of flame under the irradiation of radio wave may reach 1,500 degrees. That means that this water under the action of radio waves may split into hydrogen and oxygen. And this hydrogen will burn in the presence of oxygen. These and many other observations, from these and many other observations, it follows that electrons in water may be at a much higher state of excitation than what is usually considered. And the rather low energy of excitation is needed to make them free, and when they stick to oxygen, burning may be observed. So recent studies, very recent studies of natural or real water may explain why they behave so. And here, I would say the pioneer in these works and the leading in these works is Professor Gerald Pollux, who will give his lecture later today. Starting from 2003, he was demonstrating more and more convincingly that water phase adjacent to hydrophilic surfaces, or better to say, near the hydrophilic surfaces, there forms water and very thick layers of water, which is different from bulk water in physical and chemical properties. This thick layer of water, which is formed near the hydrophilic surfaces, is a particular phase state of water, neither liquid nor solid nor vapor. It is liquid crystalline, quasi-polymeric, coherent water, and as a matter of fact, as soon as there are tremendous quantity of hydrophilic surfaces in any living organism, tremendous quantity of biological water should have these properties. Properties of exclusion zone water, as it was named by Pollock. I will concentrate on one very important property which was discovered by Pollock, that this easy water, exclusion zone water, is negatively charged, that it is rich in quasi-free electrons, unlike bulk water, which is rich in protons and positively charged. So there is a potential difference, electrical potential difference between these two waters, and easy water may be the source of electrons. As soon as high oxygen is always present in bulk water, these electrons may stick to oxygen, and this means that oxygen is reduced and water is oxidized. So it is kind of water burning, and water burning is generation of free energy. We discovered about a decade ago that bicarbonates, which are always present in the real natural waters, they catalyze water burning. So the unique property of water is that the products of its oxidation with oxygen of water are again oxygen and water. So this is a unique reaction in which reagents and products are chemically the same. But where from energy is obtained? Energy is obtained from destruction of structured water and conversion into chaotic water. So free energy is released due to increase in entropy. But it could burn completely convert into chaotic water. In fact, again, Pollock discovered that radiation, especially infrared light or warmth, promotes regeneration of structured water from disorganized water molecules. So water can perform work by increasing entropy, and due to low density environmental energy of infrared and probably other parts of radiation spectrum, there is continuous regeneration. So water, in this sense, is a converter of the dissipated energy in the environment into the high density free energy. So we can summarize the unique properties of aqueous systems. Aqueous systems are capable of self-organization into holistic units. They may extract low-density energy of warmth from the environment and convert it into high-density free energy. They may serve the source of coherent photonic or phononic radiation. And all these properties allocate them with the capacity to receive resonant electromagnetic waves and other oscillatory impulses from the environment and actively react to them. So from this it follows that properties of aqueous systems are characteristic of living state of matter. Water, as we know, is the fundamental component and the energizer of living matter. But there is a question to which there is no answer today. Do we know anything about water origin or creation, or it is as eternal as life according to Vernadsky, or in other words, there is kind of fantasy. Probably water is and life are indivisible, as life according to Vernadsky didn't originate. So we can say now that water also did not originate. Thank you very much for your attention.
And thank you, Dr. Voykov. If you've just joined us, welcome to our Schiller Institute Symposium, The Physical Economy of the Noosphere, Reviving the Heritage of Vladimir Vernadsky. And this is our first panel, Vernadsky's Revolution in Science and Thought. You have just heard Dr. Vladimir Voykov, Doctor of Biological Sciences at the Lomonosov Moscow State University. Our next speaker is Professor Sergei Pulinets, principal research scientist at the Space Research Institute of the Russian Academy of Sciences, Moscow. His topic is A Journey Through Vernadsky's Universe. Hello. I think you're muted.
Yes.
Very
Hello.
good.
Good morning, everybody. It's a great pleasure to participate in such a conference, and I'm happy that SchillerInstitute and in the United States remember and study the heritage of the Vladimir Vernadsky. His personality is so multifaceted and comprehensive that first word which comes to mind is the universe, and it is impossible to describe or travel through the universe in infinity. So I propose you to make a short journey with few stops which are connected more or less with my research and which are based on the ideas of the Vladimir Vernadsky. And from the presentation of Dr. Jones, you heard that he had Ukrainian roots. But when I started to go more in details of the biography of Vladimir Vernadsky, and I was surprised to learn that ancestor of Vernadsky, the Lithuanian gentry Werner, fought in the army of Bogdan Khmelnytsky in the 16th century against the Polish domination. And descendants of Vernadsky, then it transformed to the modern name Vernadsky through the D, settled in the Zaporozhian Sich. Great-grandfather of Vladimir Vernadsky, Ivan Vernadsky, moved from Zaporozhian Sich to the Chernihiv province. And the most surprising thing is that my ancestor, Ivan Pulinets, was also in the Bogdan Khmelnytsky army, and he was in Zaporozhian Sich, and then they lived also, my ancestors, in the Chernihiv province. So we have the similar roots, even in details and origin. So I also can say that my scientific and educational activity were connected with both Ukraine and Russia. But now mainly I'm working in the Russian Academy of Sciences, similar to Vernadsky. Before turning to my research related to the scientific legacy of Vernadsky, I would like to say that I consider him the main scientific idea left to us as a legacy. It is the biogeochemistry, which was mentioned also by Lyndon LaRouche and other presenters in this conference. It is extremely important to our worldview, especially as we enter the era of climate change. The evolution of our planet and substance of which it consists is largely determined by the evolution of all life on the Earth. Okay, I should share with my screen. And okay. Okay, can you see this? Yes. Yes. So you see the changes of slides because sometimes it does not work. it will not help, so we will move in such a way. I will leave this and show in this way. So returning to the let's look at this picture. At the top of Mount Everest, marine limestones, fossils, cephalopods, trilobites, brachiopods, and so on were found, hinting that the highest point on Earth was once part of the seafloor. So our geological environment, our geological structure of our planet is largely shaped by the living matter. And these are called hydrocarbons, which are the vast products of living organisms, and minerals, which largely consist of remains of marine organisms and ancient oceans. This is the soil, the composition of which depends on the activity of bacteria and plants. At the same time, human activity has radically changed the appearance of our planet. This is a deforestation, mining, construction of cities, roads. All these changes not only the landscape, but also the composition of the Earth's crust. At the same time, the body of living organisms consists of the same atoms and molecules as substances in animate nature. Until now, consideration of the interaction of living and non-living things in our nature is mechanistic. Also, the meaning of this interaction is much deeper. Suffice it to say that only living organisms are able to absorb and transform solar energy. In fact, the energy of minerals is the solar energy accumulated in living substances over billions of years. This is a kind of long-term battery that helps us to survive using the energy released by sun many years ago. The next point of my speech will be Vernadsky's attitude to nuclear energy and his participation in the development of the nuclear research. Back in 1911, Vernadsky argued that radioactivity is of great importance in the life of the Earth's crust, in the fate of many minerals, and in the future of mankind. At the end of 1921, he founded the Radium Institute in St. Petersburg and became its director. He had extensive contacts and was friends with many Soviet physicists. He developed a particularly warm relationships with Leonid Mandelstam. He spoke about a responsibility of scientists to mankind, in particular, preventing the use of scientific discoveries for the self-destruction of mankind. In May 1940, Vernadsky received from his son Georgy about the discovered energy of uranium-235, and with great difficulty through friends of physicists got a reprint of an article in the Physical Review. And already on June 16, 1940, he writes in his diary, "The issue of uranium was discussed in the Presidium yesterday." Presidium, he means the Presidium Academy of Science. "I made a report, not very successful, but the result was achieved. The vast majority do not understand the historical significance of the moment. Curious, I am wrong or not? We need to send a note to the government, transform the uranium center at the Geological and Geographical Department into a commission attached to the Presidium, introduce physicists and chemists." And already in 30 of July 1940, the Commission on Study of the Internuclear Energy of Uranium was finally formed. There were several members of Academy of Sciences. You know that Kurchatov was the head of this. But actually, the start to this process was laid out by Vernadsky, and only he passed away in January 1945, so he could not continue this. Now I would like to stop on the importance of the nuclear energy, which is developing in very fast, and on the latest success. In Russia was created the industrial nuclear closed cycle reactor based on the fast neutrons, and it is already built, and successful testing of such a reactor means almost fast-free nuclear power with access to uranium-238, as opposed to classical uranium-235, which will last for millions of years. So now the new reactor, and you can see its constructed reaction, he can use the nuclear waste and all radioactive elements into its reactions, and without any pollution by radiation, it could transform nuclear elements in infinity. So this is the first step to get the new sources of energy which will stop the use of the hydrocarbons and to save our planet from the air pollution. Now let's go back to the natural radioactivity, which is a direct subject of my research. Here it is necessary to mention one more idea of Vernadsky, which called gas breathing of the Earth. In addition to methane, which is actively extracted from the Earth's crust, and which is a bone of contention in the current political situation, the Earth's crust emits a large number of different gases, including carbon dioxide, which is released 50 times more than all anthropogenic sources emit. What is the connection between the Earth's gas respiration and radioactivity? This is radon, which is the decay products of radium, which Vernadsky worked on when he founded the Radium Institute. It turned out that variations in the release of radon from the Earth's crust are indicators of the dynamics of the tectonic and seismic activity of the Earth. Here are examples of the radon variations and in anticipation of devastating earthquakes. Here you can see the radon variation before the Kobe earthquake in Japan in 1995. You see it reaches the peak, goes down, and then happens the earthquake. This is a magnitude 7.4 earthquake in Mexico. Again, you see increase of radon emanation, it drops, and earthquake. This is a series of the earthquake in Turkey. Again, you see the same shape. And this is the Aquila earthquake. The red curve shows the sharp growing of radon, and next day there was an Aquila earthquake. But it is impossible to put the radon sensor all over the world. No one country, even very rich country, cannot cover all the countries, the sensors of the radon. So we should find another way to be able to monitor its activity. How to solve this problem? This is where the ability of radioactivity to produce ionization of atmospheric gases come to rescue due to the high energy of particles emitted by a radioactive substance during decay. The energy of alpha particle emitted by radon is 5.6 mega electron volts. One such particle, only one particle, creates 3 multiplied 10⁵ electron ion pairs. And then a process starts leading to the release of large amount of the heat. Water vapor molecules in the air condense on ions and release the so-called latent heat of evaporation or condensation. This is a bit of energy that is given to the water molecule when it evaporates to make it free and able to float in the air. In this way, in the earthquake preparation zone, areas of increased temperature are created, thermal anomalies, which with the development of today's remote sensor technology can be recorded from space. Due to air mixing, these are no longer point anomalies like for radon wells, but large spots, because earthquake preparation zones have a diameter of several hundred to thousands of kilometers. For orientation, the radius of the preparation zone for an earthquake with a magnitude of 7 is 1,000 kilometers. An attentive listener will notice that with intensive condensation of water vapor on ions, the relative humidity of the air should decrease, which actually happens. And since the moisture content in the atmosphere decreases, the partial pressure of water vapor decreases, which should also lead to decrease in pressure. Such an example can be seen in the figure in the left panel of the figure, which shows the change in meteorological parameters before an earthquake with a magnitude of 6 on the island of Crete on September 27, 2021. You can see the sharp drop of the humidity, growth of the temperature, and here you see this small drop of the air pressure, and a red line indicates the moment of the earthquakes. So we see the precursor more than 1 week before the earthquake. And all these atmospheric parameters we can monitor with the parameter which we call atmospheric chemical potential, and it is the upper curve. And this is a distribution of the this atmospheric chemical potential. This is red, and it indicates the preparation of the earthquake. You can see here that this part of the map, which is the African continent, is also red because of low level of humidity and higher temperature. And how to distinguish between the natural meteorological events and preparation of the earthquakes. We have a hint is comparison of our maps with the meteorological forecast. Meteorologist doesn't know that there will be a release of the heat. And we can, from our map, to subtract the meteorological forecast again and get the pure result. There's a deviation of the atmospheric chemical potential in the region of the Kuril Islands before the few days before the earthquake with magnitude 5.8 near Kuril Islands in April 2022. So these are completely fresh results. The consequence of ionization is also the change of electrical properties of the troposphere above the earthquake preparation zone, which leads to changes in the difference in electrical potential between the surface of the Earth and the ionosphere. As a result, positive and negative electron concentration anomalies are formed above the preparation area, which can also be recorded using the artificial Earth satellites. The fact that ionospheric anomalies are regularly fixed phenomena between earthquakes is proved by the similarity of anomalies recorded over a 57 years interval over Alaska. In 1964, before one of the strongest Good Friday earthquakes in history, and in 2021, before 8.2 earthquake in Alaska on 29th of July 2025. You see the similarity, these anomalies in the ionosphere, which appears few days before the strong earthquake. In the first case, it was registered by the Alouette satellite topside sounder, which was in orbit in 1964. This was the first satellite with topside sounder on board. And now we preparing the satellite constellation, which called Ionozone, with topside sounders on board. And this is a GPS stack differential map showing the anomaly before the magnitude 8.2 earthquake in Alaska. It is also important to note the fact that the mechanism of the impact of ionization of the Earth's atmosphere is universal. It also works in cases where it is not radon that is the source of the ionization, but for example, radioactive contamination in the event of accident at a nuclear power plant. Everyone remembers the enormous environment damage caused by the accident and the Chernobyl nuclear power plant. Then everyone looked with alarm at the data where atmospheric flows containing radioactive substances would spread.
Excuse me, Professor Poulanets.
Yes.
Please attempt to summarize, because we want to make sure we stay on schedule. You can go ahead and finish, but just try to be as efficient as possible.
Okay, I am finishing. So I would like to show you how we able to monitor the radioactive pollution. This is a map prepared during the accident. And now we get the data and show how it looked in reality. And the final thing which I would like to say to you to demonstrate the effects of the galactic cosmic rays on our environment, especially the formation of the hurricanes. Galactic cosmic rays ionize the troposphere, are hitting this troposphere, but during the geomagnetic storms, the flux is reducing. And we can see what happened before the Katrina hurricane. There was geomagnetic storm, and the flux of the galactic cosmic rays dropped, and this led to the drop of the temperature of the troposphere by 9 degrees, and the temperature difference between the ocean surface and troposphere increased by 9 degrees, and which increased the vertical convection and led to intensification of the Katrina hurricane. So in this case, I would like to finish with one more idea of Vernadsky of the geosphere's coupling. And here in case of the Katrina, we have the coupling of the interstellar space where galactic cosmic rays born. Heliosphere determines the galactic cosmic rays flux intensity modulation. Sun coronal mass ejection, which created the geomagnetic storm. Magnetosphere, which produced the deflection of the cosmic rays. atmosphere ionization of atmospheric gases by the galactic cosmic rays and change in the temperature due to Forbish events, and ocean atmosphere interactions through the convection. So we have 1, 2, 3, 4, 5, 6 different geosphere. All this is our life, and this was predicted by the ideas of the academician Vernadsky. So in this place, I will stop our journey on these ideas. Thank you for your attention, and let us continue our seminar. Thank you very much.
And thank you very much, Professor Pulinets. If you've just joined us, welcome to our Schiller Institute Symposium, The Physical Economy of the Noosphere, Reviving the Heritage of Vladimir Vernadsky. We're in our first panel, Vernadsky's Revolution in Science and Thought, and you've just heard Professor Sergei Pulinets, Principal Research Scientist at the Space Research Institute of the Russian Academy of Sciences in Moscow. Now, next we are going to feature the presentations of two scientists from Italy. They're part of a project involving a total of 16 scientists that has been summarized in a book called Dialogues on Climate Between Emergency and Knowledge. And the presentation that's provided to us today is by permission of Radio Roma TV Network. The two speakers featured there also have given us permission. It's taken from a live broadcast, and for reasons of time, we've had to take selections from this. The first speaker is Professor Alberto Prestininzi. He is professor at the Sapienza University of Rome, Italy, and the director of the Center for Earthquake Research and Information. His topic is climate change and the galaxy. We will then hear a short excerpt from Franco Prodi. He is professor of atmospheric physics at the University of Ferrara and member of the Cloud Physics Commission of the International Association of Meteorology and Atmospheric Physics. He's also a member of the Italian Academy of Sciences.
Buonasera a tutti.
Good evening. I would like to thank my distinguished colleagues and scientists who have joined the initiative to publish our book and somehow managed to make sense of this very difficult issue that is caricatured by the media, oversimplifying and banalizing the issue to talk show levels, which creates very serious social problems because the climate has become political rather than scientific. Our book was created, as I said, for the specific purpose of stimulating and reopening the necessary dialogue on scientific venues, because in the last 10 years we have only seen talk show who flavored monologues that have nothing to do with science. In spite of our repeated calls for dialogue, nothing happens. We have tried everything, including sending petitions to the President of the Republic. Internationally, we started a movement that founded CLINTEL, the Climate Intelligence Group, a foundation with over 1,400 scientists from around the world revolving around the climate issue, not simply by providing different viewpoints than those of the so-called mainstream, but by using dialogue to help people understand the issue so that the majority will understand the harmful effects of the climate narrative. Our goal is to give a voice to the people who are now somehow excluded from the mainstream that someone rightly called a new religion. So we made the book hoping that people can use this opportunity with a scientific effort, because the book, although our distinguished colleagues have tried to simplify the concepts, is inevitably the result of complex observations for the multiplicity of disciplines that constitute what we, for simplicity's sake, call climate science. But in spite of being different disciplines, they are interrelated, ranging from physics to geology to chemistry and so on. So it's critical for people to understand that it's important to read, it's important to get informed and make comparisons. We don't have the absolute truth, but we have the duty as university professors to speak our mind. It's a constitutional duty, and subject ourselves naturally to comparison. What we see is a study done by about 22 scientists around the world, from different nationalities, from Australia to the United States to China, who looked at tropical cyclones in terms of frequency and intensity and recorded in the two northern and southern hemispheres a decrease in the rate of increase of the temperature from 1900 to the present. Because we are in a warm phase, and from 1800 onwards we have recorded going through various oscillations, as Professor Scafetta can show better than I can. We have had various oscillations, but there is a warming trend. This does exist, and we view it as a natural process. But the increase in temperature has not led, as they say, to the increase in extreme events. This is a refrain we hear over and over. I'm using an example provided by a number of distinguished scientists from around the world, from American, Australian, and Chinese universities, who show in detail the frequency of extreme events from 1900 to the present. The graph shows the reduction of frequency and intensity of these extreme events. That's just one example, but the same is the case for hurricanes. But vice versa, from the mainstream, all we hear is the increase of extreme events, rain, floods, confusing hazard with risk. But we don't have to get into these topics, which in any case are things I have dealt with during my entire scientific life. So it was just an example I gave in the introduction of the book, that we have to make these things clear to people so that they know the real situation. I would like to point out that we, as made clear by Professor Prodi in the book, that we have recorded data from 1800 to the present, basically measurements, experimental measurements of temperature and other parameters recorded at certain time intervals. We have ample redundant data for the past from various geographical areas. One of them certainly is the analysis of ice cores, drilling in Antarctica, drilling in Greenland, where air bubbles trapped over time up to 1 million years ago allow us to analyze the characteristics with a minimum of uncertainty of the atmosphere at the relevant time. From this, we can see we were able to adduce from this record that the climate underwent several periodic variations, which, as we shall see, can be correlated with solar activity. But not only that, the effects that the changes have left on the Earth's surface, as confirmed by the scientists practicing the discipline of geomorphology, they are coherent with these changes and the traces that they have left on the Earth. We, for example, are certain that 5,000 years ago, the Alpine glaciers had disappeared. None were left. Now the glaciers are retreating, and this coheres with the increase in temperature. In Roman times, even in Roman times, the glaciers had retreated a huge amount. The Alpine passes that the Romans used to transit to and from what we call now Europe, having conquered much of this territory, they were passes easily crossed, and you can still see traces of the work they did along these passes that are impassable today. This means that our conclusions about variations in climate, based upon the physics of the atmosphere, the sun, etc., have been confirmed not only by morphology and earth sciences, but also by examining pollen. These are redundant data that, by converging, have made it possible to create a system, for example, showing that in Roman times the Mediterranean was 2 degrees warmer than it is now. I mean that for the past we have data which allow us to say that the climate has changed. What is the issue, as Professor Prodi said? It's to try to build a model that can simulate the changes in climate. Only with this procedure we can project and make hypotheses about how the climate will vary in the future. Now, the current models are absolutely unable to simulate what has happened, and that's certain. And so, would we have the presumption to make projections with a model that has demonstrated its inadequacy, its inability to simulate this phenomenon? We should ask them this. We have invited them several times, including in August 2022, when they made an election appeal to which we are opposed. We believe that this issue should come under the scientific umbrella, and politics should come in afterwards. Politics should not direct operations. But here we would go into quite a long discourse. We have to be clear. Man, from Neanderthal onward, man has adapted and grown because of adapting, since he discovered fire. Fire is a form of adaptation to protect oneself from the cold. Or the houses, the chalets that we build at 4,000 meters, where it would not be possible to live because of the great cold, or even the air conditioners that allow you to live near the desert in Africa. So adaptation is, let's say, a fundamental appendage of Homo sapiens, and reiterating it seems pleonastic to me. However, it is. We are always adapting. When I was young, we didn't have heating or air conditioners for the summer. We suffered a little from the cold, and we covered ourselves better. And in the summer, we sought some coolness, maybe by going to the beach. Today, we adapt because we have these forms of adaptation. And so for the future, it is pleonastic to have to reiterate this. But Professor Scafetta was right to say this, because this is part of the modern dynamic of Homo sapiens, who has gone from a few billion or million units to 8 billion. This has been possible precisely because technology allows us to adapt. A different issue, on the other hand, is the catastrophism related to so-called climate change, where it would seem that we should all roast to death. In reality, we know that behind all of this, just look at the community budget, the EU budget, there are a couple of trillion euros that we are somehow discounting, and the increase in energy price is one of these symptoms. It is not separate from the reasoning we are doing at all. But we will have a chance to go into this in more detail, because by following the trail of these funds, you will get a much better understanding of what the ultimate goal of this problem is, which, from a scientific point of view, traces back to what Professor Prodi or Scafetter or the other 16 colleagues who have written in the book, and by reading the book you will be able to see it. Because, listening to Professor Prodi, there was no temptation, attempt to demonize those who think differently. We discussed as a scientist discusses, making the hypothesis possible. But that global warming hypothesis remained just that, a hypothesis. Quote-unquote scientific truth is based on facts, not hypotheses. From this point of view, it would be good to hear more from Professor Prodi.
Se posso, vorrei spendere
I would like to say a few words to elaborate on the physics challenge, and also an appeal to young people. This is the challenge of the 21st century. As I was saying before, clouds are at the center of the system because we think of the phenomenon of interaction of radiation with a droplet or a crystal. It is called scattering, and each droplet scatters radiation, which remains radiation. Some of it is due to absorption, turns into heat, but it remains radiation from the most part. And that droplet goes to transmit to the neighboring one, and this is called secondary scattering. Then the behavior of the elementary plane crystalline is of one kind. That of a complex aggregate of crystals, of a spatial crystal, has a different behavior. The cloud is simulated in the climate models as a slab, as a slice, but clouds are three-dimensional. The behavior of radiation is different depending on the height with respect to the surface at which the cloud is located. Lower clouds are clouds of water overflow and liquid water, higher ones of crystals. But the height of the cloud is important. Its shape is important. The global coverage is important. Not everything can be seen from the satellite. Very thin layers of cirrus are critical in this transfer of radiation. And that's just to stay within the scope of the atmosphere. Then there are the big unknowns, such as the heat being given off by the Earth. We know this because we have volcanic eruptions, and then in some points the mantle produces a heat outflow from the interior of the Earth that is difficult to calculate. There is an outgassing of the Earth's crust of CO2, and CO2 is also emitted from the Earth's crust and volcanoes, and these are difficult aspects to calculate. And then you naturally go to the argument that as if the CO2 is the only greenhouse gas. But water vapor is a greenhouse gas. The CO2 bands themselves can be saturated. It's a very important scientific argument. If there is a saturation of the bands, even doubling CO2 doesn't have the effect it could have without the saturation. There's methane, there are all the other greenhouse gases, and so the theoretical and experimental problems are very strong on scattering and these others that are not well known. Of course, I stop at this point because it is a scientific aspect that needs to be emphasized. However, there is the question, and here's the aspect that concerns the whole of humanity, and also the discussions that are made. How is it possible that it has developed, let's call it by its name, a hoax of global warming only caused by man, when there is all this scientific complexity to investigate? It occurred at the end of the 70s. It initiated this forum between the world governments, i.e. the United Nations, and scientists, which went on with COPs, conferences of the parties, all the way to Glasgow. The last one before that was Paris, Copenhagen, etc., without coming to a conclusion. because there can't be a conclusion with so-called scientists who are appointed by ministries of the environment. From this interaction between politics and scientists that converging from different expertise, the oceanographer trusts the atmospheric trusts the vegetation atmosphere interaction, and so on. And therefore, a confluence of opinions is formed that has become entrenched throughout the media in humanity in a way that is difficult. This book will, I hope, make a contribution, but this fake belief is so extensive that it will be difficult to bring the discourse back to science, not least because the scientists themselves are putting their own spin on it, in the sense that in the United States there would not be this encroachment of elementary particle physicists, of matter structure theorists into the field of geophysics. You respect rules, but the Italian geophysicist is not respected at all. And what's more, the media, I'm not naming names, but even calling, quote, scientific conferences, end quotes, gatherings of journalists and certain talk show people that we know we are outside the scientific method. There has been, for decades, especially also because of some scientists, a degradation of science.
Thank you, Professors Prestininzi and Prodi. And if you've just joined us, welcome to the Schiller Institute Symposium, The Physical Economy of the Noosphere, Reviving the Heritage of Vladimir Vernadsky. You've just heard Professor Alberto Prestininzi, professor at Sapienza University, Rome, Italy, and Professor Franco Prodi, professor of atmospheric physics at the University of Ferrara, Italy. We may be joined by one of them or by Professor Nicola Scaffetto, who was referred to by Professor Prestininzi moments ago during his presentation. Our final speaker for this panel is Jason Ross, Executive Director, the LaRouche Organization, and one of the central people with whom LaRouche worked 20 years ago to successfully rediscover and circulate the work of Vernadsky. His topic is Vernadsky's Economic Space and Time, the Anti-Entropy of the Noosphere.
Great. Thank you very much, Dennis. Happy to join this really excellent panel. I want to start by pulling up a few of the things that Dennis had mentioned about the work that we had done on bringing Vernadsky into the consciousness of Americans, of people around the world. The anthology that 21st Century Science and Technology produced for the 150th birthday of Vladimir Vernadsky was published in two parts, Volume 1 on the biosphere, Volume 2 on the noosphere. We published an original translation from one of the works that Vernadsky published in French, The Study of Life and the New Physics by Megan Ogden, née Roulard. And I'm going to use some of that as the basis for what I'd like to talk about today, which is there exists a profound coherence between the economic and scientific ideas presented by Lyndon LaRouche and the concepts of biosphere and noosphere as developed by Vernadsky, the great Russian scientist of Ukrainian heritage, who is the subject of our conference today. This connection is of incredible importance for countering the Malthusian green suicide cult and for charting a course towards economic growth to completely eliminate poverty on this planet and increase economic output by an order of magnitude globally. Lyndon LaRouche, he speaks of the source of value in an economy as lying not in money, but also not in physical production itself. The source of economic value is the ability of human beings, of the human mind, to create discoveries of universal principle and implement those discoveries socially to achieve an increase in our power over nature. This is measured in an increase in what we would call carrying capacity if we were animals, but which we can better call, following LaRouche, our potential population density. How many people can be supported in a certain area of land as a function of our level of scientific and social development. Economic advance is also measured in an increase in the density of application of energy in human economy. what LaRouche calls energy flux density. Now, to see the parallels between these two thinkers, Lyndon LaRouche and Vladimir Vernadsky, let's consider the distinctions that Vernadsky made between three phase spaces: the abiotic, the biological, and the cognitive, the noosphere. So these are phase spaces that include their own proper principles. The biosphere, if we look at it, it is not only living matter itself, currently living matter, it extends into the crust of the earth, to the limits of the atmosphere, by virtue of the action that life has taken to change the chemical composition of the lithosphere. The noosphere, the human race and our reshaping of the earth and beyond. Biology has had an increasingly powerful impact on the lithosphere, and human cognition has grown even more profoundly to have an increasingly powerful impact on both. And although, unlike Vernadsky, many today assume that biology must be nothing more than physics, and that human cognition is at its foundation a biological and therefore a physical process, this reductionist approach has not been demonstrated. It hasn't been proven. It hasn't been shown to be true. It's simply an axiom, a tenet of faith. Eventually, we can explain human thought by biology and physics. Eventually, we'll understand all of life purely through chemistry. It's an assumption. Is it true? Now, I'd say biology follows laws of physics, but without being fully explained by them. Music, it's conveyed using notes, but it's not contained within them. Music is not composed of notes. An idea, you convey it with words, but the words are not the idea. The process of initial discovery and of communication with others through dialogue is inseparable from knowledge itself, from the idea. Cognition occurs in a biological substrate, our nervous system, and it's affected by that biology, but it is not only biological. A couple of examples in contrasting human creativity with machine learning. There is a oneness of conception in a human hypothesis that is not found in the millions of parameters in a machine learning model. We hypothesize causes which have an existence that is really opposite to a correlation of data, of sense impressions. Human thought is not logical. It cannot be performed by a computer. So to draw out the differences among Vernadsky's phase spaces, the abiotic, the biological, and the noetic, I'll focus in the rest of this presentation on one particular aspect, the nature of time in those phase spaces, with particular emphasis on the arrow of time. Why does time flow in one direction and not the other? So to get into that, let me start with a similar analogous example in geometry, something that Vernadsky also looked into. The difference between left and right. In Euclidean geometry, there's no directly statable difference between left and right. They're simply opposites. So unless you refer to some specific object and you say, the heart's on the left side of your body, you've got a freckle on your right hand, you cannot distinguish left and right, except that left is not right, right is not left, but you can't say what one of them is on its own. Try it. Try defining left and see what you come up with. This was something that Vernadsky wondered about because in biological space, there are profound differences between left and right. Many molecules exist in both mirror images of each other as two enantiomers, stereoisomers. Amino acids, I think with one exception, are chiral molecules this way. They exist in mirror image forms, but we only see one in life. Left and right are different. Vernadsky wanted to find a form of geometry capable of comprehending this difference. He reached out to mathematicians and geometers to work on this. But let me ask, what if abiotic geometry simply cannot fully comprehend biological geometry? What if there are truly biological principles that come to bear in this area that we cannot derive or build up from the abiotic? So from that geometrical analogy, let's come back to time to look at past and future as we looked at right and left. In the abiotic world, the dynamic laws of physics, they have no direction in time. Time passes, but the formulas work the same way if you move to the future or the past. If you have a differential expression that helps you understand the evolution of a physical system, it doesn't matter whether dt is positive or negative. You can run your projections forward or back, either predicting the future path of a pendulum or recreating what must have been its past motion. There's no difference. But there do exist thermodynamic laws of physics that do have a direction in time. That time is related to what is called entropy, a measure of the amount of energy unable to do work, or sometimes called, although I wouldn't recommend it, a measure of disorder. This arises, for example, in the flow of heat from higher to lower temperatures. So if I played a video of, obviously a fast motion video of planets orbiting a star, you wouldn't know from looking at the video if I'm playing a video that's going forward or backward. The planets could have moved either way. But if I show you a video of a cup of tea in which an ice cube forms while the liquid gets hotter and hotter and starts to steam more and more, you'd say, well, the video is being played backward. Unlike the video of the planets or a pendulum or the equivalence of left and right in geometry, heat-related process clearly has only one direction in time. So briefly, the idea of entropy is that over time, systems move towards states with more ways of being. There are more ways to arrange our molecules in our cup of tea, more states for a warm cup of tea than there are states for a hot cup of tea with an ice cube. There are more ways to have air spread around in a room than there are ways of having it all condensed in a bottle in the corner of the room. If you open a compressed air tank, the air will escape, but it never goes back into the tank en masse, even though that wouldn't violate the dynamic laws of physics. So now let's take a look at biology. In biology, there are several different types of time. So you can think about the different scales of metabolic time. Think of time over a few hours. You eat food, you move your body, you excrete waste, you breathe out carbon dioxide. That's one kind of time. Over generational, reproductive time, you have a different scale. Over evolutionary time, tens of millions of years, we have another scale. The direction is clear. Over generational, reproductive time, trees as a group can move across a landscape, even though an individual tree doesn't walk in metabolic time. And over evolutionary time, life doesn't just change. It's not just different. It changes in a specific way. It advances. This can be measured in the number of elements used by life. This can be measured by the flow of material and energy through life. And Vernadsky considered this a biological principle. As an example, if we look per body mass, per lifespan, mammals, on average, use much more energy than reptiles. Mammals have additional specialized processes made possible by our endothermy, our controlled temperature. A process of cephalization has seen a concentration of nervous processes in the head, including the brain. This is a direction of evolutionary time. And unlike in abiotic thermodynamic processes where the arrow of time points towards states of greater probability, in evolutionary time, the arrow moves towards states of impossibility. Not greater probability, but improbability, of new biological technologies that simply did not exist before at all. Chemotrophs, living off of sulfur compounds emitted by hot vents in the ocean floor, the original forms of life, they can't photosynthesize. But with the development of photosynthesis, we now have an atmosphere that is 1/5 oxygen, a huge change. Photosynthesis caused immense changes in the atmosphere, the crust, the oceans. For these changes in life, past and future are not just opposites, like left and right in Euclidean space, or a positive or negative dt in dynamical physics. For life, the future reaches states that the past could not have. So now, how about cognitive time? For us, think through the completely different experience that you have personally with the concepts of past and future. And now, can you remember the future? Can you change the past? What is now For you, in your experience, how does now differ from any other moment in time, from any then? In fact, do rocks have a now? Do dogs? If there weren't people expressing our free will, how would any then differ from the now? Does a rock know the difference between now and 10 minutes ago? Without cognition, does such a difference even exist? Is there a now, a present, without us? What differentiates now from any other then, if not free will, from the difference between what we can affect and what we can't? Is now an aspect of time that exists only in the noosphere? Fundamental differences. So let's take a look at biology, cognition, and economics. Life has become increasingly independent of its surroundings, such as using the distant sun for energy through photosynthesis, rather than chemicals in its immediate environment. Life has increasingly shaped its surroundings, such as the atmosphere. Human beings bring into being new synthetic environments through the infrastructure platforms that we create, which LaRouche discussed in the introduction to this conference. This is how he saw economic infrastructure, not as a collection of pieces of rail and roadway, but as representing a certain level of technological understanding and social direction. An economic platform changes the physical space in which economic processes unfold. It creates an environment, like, take the analogy, the endothermic environment of mammals, in which new economic processes are possible. And unlike all other life, unlike change over evolutionary time, we create these epochal changes in a moment, in the twinkling of an eye, when a fundamental discovery is born or communicated. We embody in our minds a process that takes the mere biosphere millions of years. We are endowed with a now that allows us to change the future and also the past by drawing meaning from it. And this process of change is the truest substance of the universe. In improving our economic abilities by increasing our power over nature, we use more energy, more resources per person, and that is good. We also create more resources per person. We create energy. The laws of thermodynamics do not apply to human economy as a whole. It is an abiotic principle. So let me conclude. We have a role as the only known form of cognitive life in this universe to expand that process of development initiated by the abiotic universe, the formation of the solar system, the development of the biosphere, to create a more prosperous, joyful, beautiful, purposeful human society. And such efforts will bring a measure of justice to the past and the future of the lives of Lyndon LaRouche and Vladimir Vernadsky, among the billions of people who have lived and are yet to be born. Anti-entropy, growth, is our mission. I'd like to conclude by reading the last few paragraphs of my article, which appears in the upcoming or just posted issue of Leonora by the SchillerInstitute, Vernadsky in Time, Time for Humanity. I wrote at the end of this, Nicholas of Cusa maintained the primacy of the process of discovery itself, whereby contradictions drive the mind to hypothesize a new concept, not derivable from the past, a conclusion that defies the premises rather than following from them. Cusa held that it was through this process of knowing through specific ignorance that one could come the closest to seeing God. Resolving paradoxes through developing new metaphors for understanding is more than a technique for arriving at physical truths. This process is the truest substance of nature. Every human being is born with the potential to apply this process of discovery, to exist in the efficient immortality of discovering principles, applying them for the betterment of society, where that betterment is seen in increasing the capability of fellow human beings to participate joyfully in this most characteristically human of endeavors. The creation of such a society, free from the oligarchism that currently threatens global thermonuclear warfare, is the most beautiful, the most human, and the most urgently pressing task facing mankind today.
Thank you, Jason. We now begin our discussion process with remarks from the founder of the Schiller Institute, Helga Sepp-LaRouche. Sepp-LaRouche, it should be remarked, involuntarily leads a hit list or a kill list produced by the Ukrainian Center for Countering Disinformation, along with 30 or nearly 30 others that have spoken at recent Schiller Institute conferences. Now, it may be for her groundbreaking work in stubbornly advocating for a new strategic and development architecture for the world, based on the ideas of Lyndon LaRouche, with which we began today's symposium, or perhaps for her work in reestablishing how Cardinal Nicholas of Cusa created during the Renaissance the basis for modern science, statecraft, and ultimately physical economy. Or maybe it's because of her insistence that poet Friedrich Schiller's aesthetic education of man be the basis for an adult culture that will replace our self-destructive geopolitical adolescence. Whichever or whatever be the reason, it's an injustice that must be corrected. But we seek to do that by a discussion of ideas, something that Helga Sepp-LaRouche and Schiller Institute and Lyndon LaRouche have advocated from its inception. It's always my honor and pleasure to introduce Helga Sepp-LaRouche. Hello, Helga.
Hello. I greet all of you, and I want to express my heartfelt thanks to all the previous speakers, because it is so good to hear a dose of cultural optimism, which comes from the work of Vernadsky and naturally LaRouche, in this world, which seems to be sometimes gripped by cultural pessimism and entropy. But, you know, the works of LaRouche and Vernadsky are the proof that these are wrong conceptions. I want to just remind people of a work which was written by my late husband in 2005, which he called Earth Next 50 Years. And there he laid out a visionary idea about the coming integration of the Eurasian continent, and that would be on the basis of the idea of Vladimir Vernadsky. Now, I find it very remarkable. We are now about 20 years later, and what do we see? We see that indeed the Eurasian continent is integrating on the basis of the ideas of Vernadsky and LaRouche, I may say. The architects of this integration, the people who are presently working to integrate the Eurasian Economic Union, the Shanghai Cooperation Organization, the BRICS, expanding it to non-Eurasian territories, are actually talking about a no stage of the civilizational development, or a no society, which means that the ideas and the whole philosophy of Vernadsky long has entered the practical policy making of the people who are doing this integration. Now, if you look at the process of evolution, there is no doubt that there has been an increasing dominance of the noosphere over the biosphere, meaning an increase in the efficiency of ideas, of the human mind in shaping the biosphere. And that process, which has been going on since the universe exists, which probably is eternal, that is now reaching a new phase. And I think that, I want to put it up for discussion, is as dramatic as the industrialization meant a huge step forward in that evolutionary process. Now, the advances in automatization, in the production process, the advances in artificial intelligence, how that completely revolutionizes daily life, the application of digitalization, new modes of production is changing the share of people who are working in the material production completely. Less and less people are in the future going to work there in the material production, in routine work, in the service economy. This is all decreasing, and more free energy is being made possible. Now that means that more and more time of these people, it's not a threat. Robots are not a threat, but robots enable human beings to have more time for education, for the study of the laws of the universe, for the spiritual development, for practicing culture in its highest expressions, to concentrate on the aesthetic education, to become a more beautiful soul and to have a more beautiful mind, to develop one's own creativity. And, that is indeed a step which, will not be overnight, but we can already see that if you project the present visible trends into, a couple of decades from now, we will move from the realm of material necessity to the realm of freedom. Now, there will be eventually a displacement of all non-creative activities, and all aspects of human life will be transferred. For example, already visible in production, the role of nano and bioengineering will increase the strength and wear resistance and reliability of products. There will be nanomedical robots, cellular technologies in medicine, preemptive treatments, and will lead to a tremendous prolongation of life, a dramatic increase of life expectancy at a higher quality, and there will be a transformation, a revolutionary change in the chemical and metallurgical industry. So that will completely change what we have known as material production, and it will set free enormous amounts of time and energies of the people. Now, with that transformation, what we already see right now, not if you listen to the Western media, but if you look at what's actually happening with the non-aligned countries, with the countries of the global South, you see the transformation of an imperial and colonial world order into a world order which is based on sovereign nation states and their peaceful coexistence, in which the profit maximization for a few billionaires and speculators is being replaced by cooperation among sovereign nations for the common good to increase the welfare of the people. Naturally, this is not yet decided because the whole geopolitical controversy which we experience right now is exactly the fight between these two fundamentally different conceptions about man and the political order. Now, when Schiller wrote his works in the later part of the 18th century and the beginning of the 19th century, he and many other humanists of his time were convinced that mankind had reached the age of reason. And, I have thought about it quite a bit. Why was it that Schiller's expectation was not realized then? I mean, Schiller, I value his judgment enormously. He was so right on many of the universally valid aesthetical laws, which will be as eternal valid as scientific laws, which once they are discovered as being adequate, they remain in the body of knowledge. How could he err in such an important question? And the best conclusion or the best answer I have come up with is that in Schiller's time, the material conditions of production were not yet developed enough to satisfy the needs of the world population. The question of overcoming colonialism was not really on the agenda because knowledge traveled very slowly. People didn't know what was happening in Africa. It took months and months to find out what happened in different continents. But now, with this new phase in the terms of production, which I refer to be as big as the one which introduced the industrialization age, moving into the area where a lot of the material work will not be done by human beings, and human beings can entirely concentrate on their creative development. That will also allow, with existing technologies and those technologies which we already know are in process to become, this will allow easily to have enough food production, for 20 billion people, double food production and more, to have enough clean water, to have enough energy for decent housing, decent education. So the material needs of the human species in a very short period of time will be satisfied. And the human development will move to a new phase. And obviously this creates a huge challenge, because we don't want people to use that free time for stupid things, such as, surfing all day in the internet, playing video games, or doing similar stupid things. But we need to have an environment of governments working together to create the condition, what another great scientist, Kraft Erike, called the extraterrestrial imperative, namely that we as human beings are acting so much on the level of being in tune with the noosphere, being in tune with the laws of the universe, that we will regard that as our freedom in necessity, doing the meaningful thing with passion. And I think that bringing the human existence and human activity in tune with the evolutionary, non-entropic development of the universe will indeed represent a new era in the human civilization, but it will also mean that human beings for the first time will be truly human according to the dignity of our species. So I think in that sense, Vernadsky is a visionary, and Lyndon LaRouche is the agent of the noosphere, because in his lifetime, what he managed to do was to touch on so many people in writing and in person, in speeches, to increase their power of reason. So LaRouche was and is an agent of the noosphere of Vladimir Vernadsky.
Thank you, Helga. Now what we're going to do is bring up the panel, everyone that we've got at the moment. We have questions, international questions, and I'd just like to make sure I can see the screen there with everybody. And the first question, which is a general question, I see Dr. Polanet's there. I see Professor Foykov, Helga, of course, Jason, Bill. Is that Professor Scafetta who's with us? Very good.
It's me. It's me.
Okay, very good. Just wanted to make sure. Thank you. Thank you for getting with us. So what we'll do is we have many questions. Our first question will be a general question, and it is this. It's from Evgenia. The evolution of biological species, as we know it, is predominantly determined by the ability of a species to adapt to its surroundings, survive, reproduce, and increase its population. However, we cannot strongly see the connection between the timeline of species appearance and their thermogenic effect. For example, birds are descendants of reptiles, but they have greater impact than mammals like a fox in a given example. So does it mean that the evolution is determined by the amount of the energy generated by the species? That's the question. And it's a general question to put to the audience, to the panel as a whole. Does anybody would like to respond to that question? If I need to repeat it, I'll do that also, but I think it was clear. Okay,
May I
Jason.
probably start answering this question?
Okay, well, you can start, Dr.
Good evening.
Voikov, if you wish, and then Jason will.
Yes. Well, first, our concept of evolution, which is a textbook concept of evolution, is changing. In fact, during the last 2 decades, very significantly. I would say that we now return back to Lamarckian principle of evolution, unlike modified Darwinian principle of evolution. As a matter of fact, Darwin, besides that he suggested his own the survival of the fittest, he was the fan of Lamarck in a sense of the mechanism of adaptation. By adaptation, one could at that time understand not just adaptation to the current conditions of the environment, but also ability to change these conditions, that living things were able to change these conditions, and this was also a part of adaptation. So that means that according to the classical understanding of Darwinian theory, living things are just like machines. They are, in extreme case, inanimate. According to Lamarckian principle, living things are subjects. They have, as he said at his time, the internal drive for improvement, for perfection, and so that was the essence of the living state according to Lamarck. By the way, if we just think what in general Vernadsky was speaking about the evolution principle, because he also discussed a lot about evolution, he was much more close to Lamarck than to Malthusian Darwin approach. Already it was said here at this conference. So the living things have this intrinsic property of perfection, and this perfection just means that living things are capable to increase, according to Vernadsky, the flow of substances through them, but also they do it due to the concentration of energy. They become more and more energetic. And in fact, there are several scientists who demonstrated that in the course of evolution, it doesn't, from more primitive to more advanced, the quantity of energy which is transformed by representatives of different species or even classes of living things, they increase in evolution. And the human being, from this purely physiological point of view, I'm not just talking at all about his consciousness and so on, he is most energetic physiologically creature, I wouldn't use the word creature, living system among all other living systems. For example, it's only brain of a human being can consume 20% of oxygen, though the mass of the brain is only about several percent of his body. So if to compare the energetic, so to say, the energetic turnover of different living systems, we are really at the top of evolution ladder, just basing on physiological principles. And this ladder, it increases if to compare the mammals and birds with the worms and more primitive animals. So it grows and it grows. But as a matter of fact, this is a geometric progression of increase of energy, energy consumption and transformation. So that is just the natural. Again, we can state that this is kind of empirical generalization. As Vernadsky liked to say, that the major achievements of science is to understand these empirical generalizations. It's not theories, it's not hypotheses, but empirical generalization. It is the major product of science. So this directed, and that is very important, directed evolution, which finishes, according to, say, Vernadsky, the evolution of biosphere, I wouldn't say finishes, it continues into noosphere. It is also the not a chance, some kind of chance. It could be predicted from the observation of what evolution is. I don't know if I managed to answer this question, but at least this is my point of view.
Okay, Jason?
Yeah, well, I'd like to I think Dr. Voyakov did answer pretty thoroughly. I'd like to point people towards a reference on this, that in the 150 Years of Vernadsky, Volume 2, the noosphere, there's an original translation, The Evolution of Species and Living Matter, which is an appendix to the French version of the book, The Biosphere by Vernadsky. And in this, he talks about, this is one location where you can read about the increasing biogenic flow of atoms and of energy. And I sort of actually want to, I think this raises a question to me, in that in your presentation, Dr. Voyakov, you referred to Vernadsky's view that the quantity of living matter, and I hope I get this right, that the quantity of living matter is constant, even though its flow and its energetic dimensions take on higher forms. I wonder if you see any contradiction there, or?
No, I don't see any contradiction. Evolution is changing quality. You don't need to change in quantity, because just increase in reproduction, you don't need to increase in reproduction to become more clever. I would say, you see, that is education which makes people more clever than their reproduction. I would say it's even opposite. When people reproduce too intensively, they become less clever in general. So the general, you see, in principle, the quality of biosphere is, when we are talking about evolution, that is increase in quality of species and their interactions with each other. Again, in classical approach of evolution, there is no even understanding that it is evolution of a biosphere, that is interaction of different species. They cannot live without each other. That is just what we now call ecology. See, and this increase in the quality of interaction, increase in the complexity of system, that is also the evolution. You see, when we are at least we can observe evolution starting from the unicellular microbial world. It is tremendous in quantity. The quantity of microbes on Earth, we simply don't know this. We don't pay attention to this. And probably the quantity, at least the quantity of microbes even in our body are about 20% of our body. And the quantity of microbes is 10 times more than the quantity of our cells in our body. But we cannot live without them, and they cannot live without us. So that is ecology even of our body. But I would say that probably I can suspect that I am a little more clever than my microbes, though I cannot live without them.
Can I just add?
Sure.
That is increase in interaction. The collective process. Evolution is the collective process. It is not the evolution of the isolated species. Isolated species die out.
Yeah, Bill?
Can I just add something and bring in this idea of energy flux density? I mean, if I understood the question correctly, is the amount of energy that's produced by different species. We're now entering into a realm where we're going to be developing thermonuclear fusion power. The presentation in the afternoon will talk a little bit about this. This is a tremendous amount of energy density that we can think of, because it is taking the energy that's produced in the sun, the same process, and bringing it down here to Earth. And so that takes it up even a notch further. No, no other species can do something like that. So I think that's clear for that question.
Again, it's I suppose it is our habit to concentrate on the quantity of energy. You see, the quality of energy, what is much more important? And by quality of energy, well, I agree with some physicists like Emilio Delducci and things like this. We understand by the quality of energy first, the concentration, how energy is concentrated, because energy which is dissipated has much lower quality. You see, a great tank of warm water can produce much less work than a boiling teapot, I suppose. You see, so the quality of the concentration of energy is very important. But what is now becomes even more important, that is organization of energy. Because you see, our energy, we can produce tremendous quantity of work, not because we contain so much energy, but because energy in our living substance is highly organized. I can give only technical examples, like, for example, you have a light flash and laser, and one small battery can give energy to a laser and to a light flash. But with light flash, you can illuminate a small surface only. But with a laser beam, you can illuminate something which is kilometer from you. The quantity of energy is the same, but laser light is organized and it doesn't dissipate, you see. So that is the quality of energy. Quantity is the same, quality is tremendously different. Our energy, living energy, is laser-like energy. So that's why we do not need to have you see, if we consume more energy than we need, then we become sick.
Oh.
We should organize energy which we consume. That is the major problem, you see, and we can organize this energy, organizing our matter. And as I said, the major part of our matter is water. And by the way, I didn't say about one thing. When we're talking about consciousness, it's a lot of different definitions of consciousness and so on. But there is one which everybody will agree, that consciousness is connected very much with our brain. I suppose if we don't have brains, then we don't have consciousness, I suppose. So brain is very important for consciousness. Brain is the most sophisticated organ or substance in the universe. And it is one of the most wet in our body. And when we study brain activity, we study it using nuclear magnetic resonance or imaging. And we study, when we use this nuclear magnetic resonance, we study the activity of brain by the changes of the properties of water. Because MRI, magnetic resonance imaging, is just measuring the state of water. And from the state of water, we make so many conclusions about the activity of our brain, about the pathologies in our brain, and so on. And so then here there is a link from brain to the consciousness, and that it is our consciousness is not located only in our brain, but can be connected to your brain and other brains also, by different means.
Yeah, Professor Voyakov, let me just break in here, just because you've prompted a lot of different questions there. You're getting various questions, but I want to also make sure, because I didn't properly introduce Professor Scafetta.
Yeah, I'm sorry.
He is done. He's a research scientist at the University of Napoli, Federico Due. And he was also an adjunct professor at Duke University. And there's a question for you, Professor, referring to the video that we saw from Professor Preston Inzi. But you were not able to feature it in the video. And then you had work on the influence of sun activity on climate, which was mentioned. Can you tell us what your discoveries are, what you've worked on, or anything else actually about this book project, which we referred to and people were somewhat excited about?
Yes. Do you hear me?
Yes.
Yes. Yeah. Oh, okay. Yes. No. So together with Prestinizzi and many other people, we have written this book that I show you again. This book that dialogue on climate. And the purpose of the book was just to address many topics related to climate change. So, of course, I am a physicist, so I addressed the physics of climate, and many other people addressed the economical, financial issues, and so on. So I think that is a very interesting book that we were able to collect. Now, about my contribution, I did two things essentially. So I wanted to test the anthropogenic global warming theory essentially. And you know that anthropogenic global warming theory is something that comes out from climate models. Because of course we observe a warming of the earth, a warming of the climate since 1900, but the open issue is to understand how much of this warming was induced by humans and how much it was induced by natural phenomena, natural cycle, natural climate cycles. And the problem is that the models used by the IPCC tell us that humans were responsible for 100% of this warming. So practically natural variability, so in particular solar activity or natural cycles, natural climate cycles and so on, did not contribute at all to the warming observed from 1900 to today. Now, the problem is that this interpretation of the climate system is at odds with what we know about the climate system in the past. In the past, we observe large climatic cycles. So we observe, as Prestinizzi said, warm periods like the Roman period or the medieval period. These were very warm periods. So during those periods, the glaciers, for example, on the Alps were restricted, were much smaller than today. And we have a lot of evidences of this situation. Therefore, to claim that the warming observed from 1900 to today is due to humans, and that natural variability did not matter at all is something that does not make any sense, essentially. And why this computer model theory should be questioned? It should be questioned because the same models, the same climate models used by the IPCC contradict each other, essentially, in the sense that these models predict a climate sensitivity, an equilibrium climate sensitivity to CO2 that varies between 1.8 and 6 Celsius. So the climate sensitivity is an index that indicates the warming induced by doubling the amount of CO2 in the atmosphere. So these models predict something that goes from 1.8 Celsius to 6 Celsius. And this is a huge uncertainty. And when we test this model, So in particular, I tested whether this model were able to reproduce the warming observed between 1980 to 2022. So it is very easy to see that the models with medium or high equilibrium climate sensitivity are running too hot. So practically they don't agree at all with the temperature records that we have. This means that at most only the low equilibrium climate sensitivity models may be trusted if there are no natural oscillations and if solar activity did not contribute to climate change during the last century. But that then we can prove quite easily that there are natural oscillations and that solar activity very likely contributed significantly to the warming observed from 1900 to 2000. The reason is that the models actually do not use the solar records that show a large secular variability. So practically, there is a large uncertainty in the scientific literature regarding what the sun did. And there are a few records that show a very low secular variability. So practically, the solar activity was almost constant in the last 100 to 200 years. And there are other reconstructions of solar activity that show a much larger secular variability, up to 5, 6, 7 times larger than the latter one. And the climate models use the solar records that show the least secular variability. Of course, this implies that the sun did not contribute at all to climate change during the last 100 years. But if we use, for example, solar records that show a larger variability, a larger secular variability, the sun might have contributed at least 50% or more of the observed warming. Another shortcoming of the models is that the climate records that we are using have a lot of problems, because there are many evidences that the surface records are affected by local biases, such as urban heat islands and so on. So a lot of local biases that people are not able to clean, to filter off. So they try to filter off all this bias, but indeed the analysis suggests that a little bit of this bias persists in the data, and this bias the reconstruction, the climate reconstruction toward a higher value. So it is likely that the 1 degree Celsius that has been observed, the warming, the 1 degree Celsius of warming that has been observed from 1900 to now, to today, probably this is too high, too much. Probably the real thing is 0.7 or 0.8, so it's something small. Now, if we put all this information together, that the models don't use the solar records with a higher secular variability, then the models with a high or even medium equilibrium climate sensitivity, so that is an equilibrium climate sensitivity above 3 Celsius, fail to reconstruct the observed warming from 1980 to today. And 3, that the climate records themselves show a warming bias. So if we put together all this information, we came out with the conclusion that the climate sensitivity should be relatively low, that practically most of the models used by the IPCC are wrong, and that, of course, the climate change for the future that this model proposed is wrong. So the climate in the future will continue to change. Perhaps it will warm a little bit more, but my conclusion is that the climate will not warm so much to become dangerous for humanity. And therefore, we need to address the climate change issues using adaptation policy and not mitigations one. Mitigations policy are very harmful for society because are extremely expensive. Very likely they will have a little effect on society and on the climate. They will have a big effect on society, but a very little effect on the climate. And this, in our books, there are a lot of several economists that address this point, and they show that any attempt to mitigate the climate, so by reducing drastically the emission of CO2, so was not successful because CO2 emissions in the world have increased continuously since 1990. They continuously increased. So nobody was able to stop this increase, even though in Europe there was a reduction of this CO2 emission, but in the rest of the world, in China, in India, and so on, there was a huge increase of emissions. So very likely the mitigation policy will not be efficient at all. They will only harm Western society, and they will do nothing to the climate. Instead, the adaptation policy will be very successful and can be applied everywhere in the world and where they are truly needed. So this is perfect. So I would like to stop here.
Yeah. But thank you, Dr. Scafetta. We just have a lot of questions. And I realize I just want to know, does anyone have anything to say in response? If so, I just want to note it. And if not, let me pose another question, which is a general question. And let me indicate I have a question specifically for Dr. Pulanets, and I have a question for Dr. Voyakov. But I'm going to go to the general question first. This is from Gleb Olejnik, and he is asking the panel this question. According to the postulate that human discoveries will always be endless, and the laws of nature associated with them will always remain unchanged, is it possible to assume that the laws of nature will still change if we also assume that humanity would someday reach the limit of its research and studies? Who would like to take that question?
I would just say that I don't think there is any end to this. And you can all go back to Nicholas of Cusa on that as well, that, you're working with the infinite in terms of development. It would only stop if mankind stopped its development. If mankind stopped its development, it would probably cease to exist as a species because of, the underlying lawfulness of the energy flux density that Mr. LaRouche talked about. And I don't think it will end. There's no reason to assume that that's the case. We don't know. The laws of nature, in fact, you probably will see will also change. I mean, you come back to this issue of the change of the change of space that Vernadsky talked about. he indicated, of course, like if you're looking at the microscopic level, it's different than on the macroscopic level. And also, as you go out into the galaxy, you may find different forms of lawfulness in which our views of space and time change as well. And this is what I think Mr. LaRouche was talking about in terms of the Riemannian geometry. And so that this will be a never-ending process. I can't see an end state to this. I mean, if you're a theologian and you're reading Teilhard de Chardin and his sense of the noosphere, you'll get to that omega point. But for mankind, I don't think there is an omega point. I think you're looking at continual frontiers that have to be overcome as we move out into the galaxy. And there's no reason to think that there is some kind of an end point, at least from a scientific point of view. From a theological point of view, maybe accepted, a philosophical point of view. But this was rejected by Vernadsky, and I think from the point of view of science, this will not be the case.
Okay. I have a question for Dr. Pulinets, and this is from Kynan. He asks this. Dr. Pulinets, I know that you have done a lot of work concerning certain technologies that can be used by mankind to stimulate rainfall, specifically using ionization systems. Many people are unaware that research is even being done in this field, and that weather processes and climate could even be controlled in this way. Considering the previous presentation by the Italian scientists on the way climate is misunderstood, could you speak more to your research on this subject?
Okay. The ionization processes are characteristic for all our environment. For example, the cloud coverage of our planet in great extent depends on the fluxes of galactic cosmic rays, because they ionized the molecules of atmospheric gases, mainly in the altitude of the tropopause. And these ions start to be the centers of water condensation, and clouds are formed. So the technology which was proposed only repeats the natural laws, and contrary to cosmic rays which ionized our atmosphere from above, there were created the installations which produce ionization from below, and then this nucleus of condensations go up and also can create clouds, or you know that electricity has two signs. So depending on what potential you put on your installation, positive or negative, you can disperse the clouds or create. So this technology was used to fight with droughts in Mexico, creating the artificial precipitation, to fight with forest fires at Yucatan Peninsula. And then I know it was applied in other countries, for example, in Saudi Arabia, Australia, and so on. But in general, the traditional, if you can say traditional, meteorologists do not accept this. So this technology was not developed widely, because the companies which were created and produced this installation lost their financing, and this activity practically was stopped. Sorry.
Okay. Okay, thank you.
My answer, yes.
Okay, thank you. This is a question for Dr.
Laws of nature, let me say, I think that laws of nature do not change. Simply, we note these laws not to the end. We have these laws as approximation to the reality. And with time, when we will new discoveries maybe it will be changed, but it will be changed our knowledge, but not the laws of universe.
Okay. All right, I'm going to pose the question to Dr. Voyakov, and perhaps others will have remarks on several of the things that have been said. So this is from Peter Martinson, actually, to you, Dr. Voyakov. He says, "Greetings, Dr. Voyakov. You gave an interview with 21st Century Science and Technology magazine a while back where you referenced the work of a man named Kozlov on mitogenic radiation. Mitogenic radiation, discovered by Russian academician Alexander Gurevich in the early 20th century, is radiation emitted by living cells as part of the life process. In your interview, you mentioned that Kozlov studied the possible triggering of cellular mitosis by Cherenkov radiation, which is produced by energetic beta particles passing through cell cytoplasm. High-energy beta particles exist in the flux of galactic cosmic rays that pass through our solar system and enter the Earth's atmosphere. This flux changes due both to solar activity and the motions of the solar system through the disk of the Milky Way galaxy. In your view, is it possible that the changing flux of galactic cosmic rays could interact with cellular activity in ways that mimic Gurwich's mitogenic radiation? Thank you much for your time."
Thank you for a very good question. Well, first I try to answer this question and then dwell a little on the two previous problems which we discussed here. Yes, in fact, I published, as a matter of fact, three papers in 21st Century Science and Technology. And one was which was called The Scientific Basis of the New Biological Paradigm in summer 1999. Then what distinguishes living systems from non-living systems? Also, it was more than 20 years ago. And Are Carbonate Solutions Alive in fall 2011. So I'm closely connected for a long period of time with the 21st century. Now, about Gurevich and Kozlov, I'll try to be just brief. In fact, the cell division needs a trigger. And this trigger, as it was discovered by Gurevich, are ultraviolet photons of very low intensity, which originate in our body from many biochemical reactions, from free radical reactions, and so on. What Kozlov has shown is also the development of these studies. He has shown that the Cherenkov radiation, which originates when very high energy beta particles they originate in water, they convert into ultraviolet photons, a flux of ultraviolet photons, and these and this phenomena also serve not only the cell division, mitogenetic radiation, but they excite very many living systems, or in fact, the living matter or living substance, as I call it here. Now, we have in our body always, our body contains radioactive elements which break down, giving such Cherenkov radiation. This is potassium-40. We cannot live without potassium, and potassium concentrates in the nucleus of our cells. And this potassium is radioactive, it's natural radioactivity, and it was shown that if to purify potassium-35, which is not radioactive, from potassium-40, then living system just decays. So this is our internal sparks, I would say, this potassium-40. And probably also the radon may play such a role and other radioactive elements. As regards the external radiation from sun, high energy particles from sun, and so on, I don't think that they directly can affect what happens in our body. But what they really do, they produce split water, which is practically everywhere, as Vernadsky said, both in atmosphere, ionosphere, and in liquid water on surface of Earth and under surface of Earth, and so on. And this sun activity, it affects this water. And by the way, one of the results of this effect is appearance of superoxide anions, radicals. That is, again, ionization of water. Without this, they are known under the name negative air ions. And it was demonstrated also by Russian scientist Chizhevsky more than 100 years ago, that without these negative air ions, these are oxygen ions, we cannot live in general, and they regulate a lot of our activity. So here is just a link to what the previous lecturer was talking about. We as living systems need very much this ionization. So that's, I hope that I managed to answer this question, that these beta particles are very much needed. We cannot live without them, and we cannot live without ionization of air and ionization of water, as a matter of fact. And now a few words about the laws of nature. Well, if we understand the word law as a law which was adopted by the academies of sciences, which consider themselves as parliaments, which adopt this or that law. And when they adopted this law, they considered that this law is eternal. In fact, I much more sympathize to ideas of Rupert Sheldrake, who is talking not about laws of nature, but habits of nature. And for example, one of the laws which is considered to be eternal law of conservation of energy. Now it became clear that we understand only about 10–20% of energy, and all the rest, who nobody knows how much, is so-called black energy, as black matter. The law of conservation of energy, it is needed very much for us in our ordinary general practice, but we cannot use it to understand the universal habits, the habits of the universe. And that's one point. That we don't know to the end the real regularities in nature. That's one point. Another point, there is evolution not only of life, but if life is of the same order of magnitude as energy, time, and space, as Vernadsky said, there is evolution of energy, time, space, and matter, and life. And this may be co-evolution. And who knows where this evolution will come. So these habits are changing continuously. So we're living in a changing world. So as regards human laws, they also evolve with the evolution of societies. So these, what we call laws of nature, they should evolve continuously, and then we cannot call them laws which are unchangeable. So that's my. I agree with Bill that there is no fixed laws. They are processes. See, the habits of nature are processes, and we, as part of this evolving nature, we can change them. As a matter of fact, in principle, humans can change what they call laws of nature. In principle, I don't say. I have no recipe how to do this, but in principle, it is possible.
Okay. I have a question I'm going to put in here, which I was intending to put in anyway, and resist any comment because moderators aren't supposed to do that. This question is directed to you, Jason, and anyone else that wants to tackle it. It's from Ernie. It says this: in 2009, Lyndon LaRouche wrote several lengthy articles, in particular, Economics as History, and others. He was introducing his highly original concept and theory of dynamics as a universal principle governing all three of Vernadsky's phase spaces, and each of those was seen as a Riemannian manifold of interacting physical principles. He proposed that relativity is a principle of dynamics, and as such is operative in all three domains. The phenomena, therefore, did not necessarily involve the speed of light as a boundary condition. Rather, the variables were appropriate to the domain. He referenced Vernadsky as, quote, correcting Einstein. Work done by a team of young scientists under LaRouche's guidance explored the work of Vernadsky on the space-time of living matter and found strong corroboratory evidence for LaRouche's hypothesis, particularly in the relationship of energy flux density in physical economy to Vernadsky's biogenic migration of atoms and to the, quote, intrinsic time of every mammalian species studied, illustrating Einstein's relativistic time dilation. Based upon this finding and allometric data on many species of placental mammals, the team coined a new energy mass time unit, the Vernadsky. What do you see as the implications of this discovery for the future of biology and science more generally?
I think it was a preliminary hypothesis that I don't believe is true. So just to restate the question here a bit, what Ernie is referring to is that by looking at, so there is, among classes of animals, if we compare reptiles, mammals, and birds, overall, for reptiles, on average, there's a certain amount of energy that's used per gram of adult body mass per lifespan. You could get a similar number for mammals, you could get a similar number for birds. This is what the questioner is referring to as a unit of Vernadsky's. The dimensions of it would be this energy use per body mass per lifespan. Some preliminary analysis using a database of metabolic rates and also lifespans suggested that for the class of mammals as a whole, there was a characteristic level in terms of Vernadsky's for mammals, a certain level of energy, mass, time for them as an entirety. The reason for looking at this is that metabolism grows with the size of an organism, but not linearly with its body mass. Similarly, the lifespan of an organism typically grows with its size, but not linearly with body mass. In the first case, the growth is at about a 3/4 ratio. In the second, it's at 3/4 power. In the second case, it's at a 1/4 power. If you combine these and look at metabolism per lifespan, then there's a potential that these two powers would come to unity and that you would arrive at a sort of a space-time matter unit that would be directly related not to mass, not to time alone, but mass and time to give a quantized nature of life. That when we look at life with a quantized time per lifespan or per time to reach gestational time or whatever, that there would be a number that characterizes a class of animals. And that therefore we can see that over evolutionary time, there is a greater flow of energy, a greater flow of matter, as we've discussed earlier in this panel. With that, I agree that the flow increases. However, because I was looking back at this when finishing up this article that's in the issue of Leonora that just came out, and I really can't conclude that it's fair to say that there is a number that characterizes mammals as a whole. There's just too much variability within the different classes of animals. For example, between flying and non-flying mammals, bats, the difference is quite large. Among birds, flying birds versus flightless birds, the difference is also quite large. So I think it's a useful way to look at energy flux density as applied to evolutionary development over biological time. I think that's very reasonable. I'm intrigued by the hypothesis of a quantized time and this unit of the Vernadsky that the questioner brought up. But to me, the variability within the classes is large enough that I'm hesitant to say that it makes sense to try to look at one number that characterizes such a broad variety of life as you could say at the class level of classification. So that's what I think about that.
Okay, very good. I think that illustrates the whole purpose of this conference, which is the notion of inquiry and exploring ideas. I think it's important. And we have another question here. This is going to be for various of you who will probably want to answer this question. This is from Michael. And he says this. He says, the panel has jumped from the biosphere to the noosphere while omitting the technosphere. Firstly, as the noosphere is rooted in consciousness, which precedes the evolution and formation of the brain, surely our exploration, understanding, and translation of consciousness and its generation of the noosphere is our starting point and first priority in our discovery of knowledge. Second, why no mention of the technosphere by the panel, or do they mistakenly view it as the same as the noosphere? Thank you. Looking forward to hearing from you. Who would like to take that? Bill, I see you smiling. Are you?
I think it's included in the noosphere because what you have, the basic process is the creative thought, the thought of the mind, which then, when it's transmitted into practical implementation, becomes, what can you say, the technosphere. But the basic procedure is this, the creative thought of mind. And you have to understand that Vernadsky also thought about this a lot. I mean, he would come into these states and say, all of a sudden, he was not thinking in a directed manner, but then thoughts would come up that he realized it, and then you had this aha moment. And I'm sure that's also the case in the experimentation that people were doing with fire, so many thousands of years ago. That is really the key. And what's called the technosphere now, I think it gives a wrong impression of the nature of scientific development. You got this idea that there are geeks working in the laboratory, with their computers, everything, coming up with these newfangled gadgets. But the basic principle is the creative thoughts of mind, the individual who comes up with a creative idea. That's where everything starts. The rest is really, we say rest is history of implementation. A lot of creativity has to be involved in that, in the engineering as well. But I think the noosphere pretty much covers that as a development of human industry.
Okay, I'm going to. Sorry.
Can I add something?
Sure.
To this? I think that technosphere, it is a carrier of our knowledge, carrier of our conscious, and sometimes some people present noosphere as something like thought are flying in the environment. They are not in the environment. They are in the products which we do every day, and all the industry, it is a carrier of our knowledge and our thoughts. So it is part of the noosphere, very important part, condensing the products of our brain.
Okay, I'm going to basically take one final question and then come back to the panel members and let people summarize. This one is going to be directed to Dr. Voyakov and also Professor Scafetta. And it says this, it's from Amber. It says, in the field of inorganic chemistry, there is an emphasis on the matter of static measurement, atomic and molecular weight, etc., and those equations which measure the molecules and or the matter once it has entered a new state. I often use the matter of the excitation of the carbon molecule, matter which has the happy habit in most cases of creating new states of matter through compounding. The Malthusians often use the compound of CO2 in isolation or in a closed system as being a poisonous toxin, in complete disregard or ignoring the knowledge that carbon assists living systems in a most extraordinary way. How is it best to be able to overcome this in terms of your references regarding the principles of stable non-equilibrium? You made mention of Erwin Simonovich Bauer in 1935 and his work. This seems that it might be useful if understood better. So this is directed to you, Professor Voikov, and then if Professor Scafetta wants to make a comment.
Thank you for this question. You see this contradiction between the university inorganic chemistry and living processes is just contradiction between static and dynamic, or dynamic approach to science. Of course, it is much easier to study photographic shots than to study the contents of the movie. But we live in continuously changing world, and from recent time, more and more attention and more technique originates, which shows us that the world is continuously changing, that there is continuous difference and so on, and also things interact with each other. So just our standard approach to chemistry, this becomes more and more outdated approach. We should study the continuous change even of chemical solutions, of chemical reactions and so on, and interactions between different substances. So from this point of view, Bauer's definition of living systems as being in stable non-equilibrium describes wider and wider the range of objects or subjects, because nearly practically everything becomes in this stable non-equilibrium state. And this now, from my point of view, connects more and more with Vernadsky, who stated that life animate state is the primary state, and inanimate is the product of the animate state of a living matter, of a living substance. So the problem is in our, I would say, system of education, which we continue to teach students about the origin of life. And I, one of the few probably professors at the Faculty of Biology who, basing on Vernadsky ideas, says that it is just a wrong notion. There is no origin of life. Life existed like everything, like energy, like matter, like time. So life is of the same level. And if life is primary, then the non-living things are secondary. And we observe it practically every day when we see that living things convert into dead things, but we never see that dead things convert into living things. So the problem is that we should change the methods of investigation from studies of steady state or stationary state or fixed state to the study of the processes. This is not very easy. I would say this is very difficult because of the system of education.
Okay. And Professor Scafetta, any comment?
Yes, I have some comment regarding CO2, regarding carbon dioxide, of course, from a climatic point of view. So from a biological point of view, it's obvious that the CO2 is the food of the plants. So without CO2, life would not be possible on our Earth. Therefore, CO2 is not toxic. is not a pollutant, is not dangerous for human life in any way. So it is just a green gas. I would call it the most green gas that the atmosphere has, because without CO2 there would be no life at all. So it's very important for us. Now, why people say today that the CO2 is a pollutant? The people tell this just because it is claimed that the CO2 as a greenhouse gases can warm up the earth. Okay, so all greenhouse gases can contribute to the warming of the atmosphere. But CO2 is not the most important greenhouse gases. Water vapor is the most important greenhouse gas, and then clouds together with water vapor control climate change, and so in many ways. Now, why CO2 should be dangerous then? It is a product of computer models. So it is the computer models, computer climate models, that claim that CO2 is dangerous. And it is so because these computer climate models, as I said before, predict a very high equilibrium climate sensitivity, which is measured in function of doubling the CO2 in the atmosphere. But as I said before, it's very likely that most of these models are wrong, because the equilibrium climate sensitivity is low, is relatively low. And therefore, CO2 cannot warm, increasing CO2 in the atmosphere will not be able to warm the atmosphere so fast to make the climate change dangerous for human societies. And therefore, this idea that the CO2 is dangerous for humans is just a hypothesis connected to climate models that are failing and failing and failing. So that is my message. So in these situations, we cannot ignore that CO2 is food for the plants. That CO2, the increase of CO2 that we have observed in the atmosphere has increased the agriculture production. The planet has become greener during the last 50, 60 years because CO2 is food for the planet. So it's a good thing, it's a good thing. So we need to understand well this, that CO2 is a good thing. Those who claim that CO2 is bad, they do that because they believe in climate models that are failing. So that is my message.
Okay, very good. So we're going to now move to conclusion. We have about 15 minutes to do that. And so we have 6 of you, I believe, and that means you have 2.5 minutes each. But let me just be more specific. What I'd like to do is to go to Professor Poulenetz first.
Okay. I'm very glad that we have this meeting, because for the first time I have seen the serious approach to Vernadsky ideas. And in this discussion, we see the real development of these ideas. So I propose to make such meetings regular, to follow up the progress in our research. Thank you very much. Thank you for all presenters. It was very interesting to me. And I wish all of you all the best, good health, and to the next meetings.
Thank you very much, Professor Poulenetz. Professor Scafetta.
Yes, so I would like to thank you for inviting me to this meeting. And I hope that the message that I tried to send, and also the message that my colleague in this book, unfortunately, the book is in Italian, so you will not be able to read it. But I think that this book is very useful because it addresses all aspects of around the climate, no? So the scientific aspect, but also the economical and the financial aspects, and so how climate interact with humans and so on. So I believe that it's very important that people understand better these issues, because what is today said in the media and so on do not really correspond to the truth, and it is a banalization of the issues. So people need to understand that the climate from a physical point of view is very, very complex, first of all, and is not CO2. You add CO2 and climate change. No, it's not like that. It's much, much more complex. On the other side, people need to understand the economical, financial aspect of climate behind these issues. So there is a lot of speculations, financial speculations, a huge amount of speculation, and this may be. And if people do not understand the real issues, it may be very dangerous for society. So we hope to help people to better understand all these issues.
Well, thank you very much, Professor Scaffetta. I'd just like you to know that there is a rumor of a conspiracy, sort of Vespi Siciliani style, to get the book published in English. I'm not privy to being able to reveal the origins of the conspiracy, but perhaps more will be heard soon. Bill?
Let me say, there's three things that were important of what happened today. One, of course, is we're getting the message out of what the real Vernadsky is in the Western world that really has not been understood. And I think we made yeoman's service in doing that today. Secondly, we have introduced the relationship between Lynn and Vernadsky, which also is not very well known by the world. And I think if they had been more contemporaries than they actually were for a short period of years, and Lynn went to Russia and Vernadsky were alive, they would find themselves as kindred spirits, much as he did with the followers of Vernadsky, whom he did meet with when he was in Russia. And that's also very important. And I think it underlines not only his role as a political leader, but also his role as a scientific thinker, which came out, I think, very clearly in this. And the third is that, of course, we've got a group of scientists from Russia, from Italy, and also in the afternoon from Egypt, from the United States. This is something that is not happening these days because of the bifurcation that's being attempted by, among others, the Biden administration to split the world into these warring camps. I think we took a big step in showing that that's not the way to go by discussing profound ideas amongst these different groups. I think that's the directionality of this thing. And I think we've proven that today, that this is a better model, a better paradigm than what we have today.
Thank you, Bill. Professor Voikov?
Yes, I also want to thank very much the organizers of this brilliant conference. And first, I agree completely with Professor Palinets that the conferences or talks, such free talks devoted to Vernadsky, are very much important. And I would also like only to add that I'm very unfortunate that Vernadsky's name practically is not known, not only for Western scientists, but frankly speaking, the Eastern scientists also. He is not a very popular person in Eastern science. As a matter of fact, he died in 1943, if I'm not mistaken, but his major work began to be published only in 1960s. so it's more than 20 years after his death. And as a biologist, as a professor of the Faculty of Biology, I would say that if we ask our students of biology about Vernadsky, what he made and so on, very, very few of them will tell us what he really has done. So such meetings are very much important because independent of our knowledge or not knowledge of Vernadsky, there is this evolution and there is transformation from biosphere to noosphere if we want it or we don't like it. We want to separate the society into individual divisions. No, the process is going on. And the better we know the ideas of Vernadsky, the better we know the origin of this new state of humanity. I think the easier and less bloody will be this phase transition from separated humanity to unified humanity.
Thank you very much for that, Professor Voikov. Jason?
Speaker.
Thank you. I'd like to agree with what the others have said, that this has been a real treat, and I hope to make these a regular occurrence. And also in terms of building up reading groups or greater familiarity with Vernadsky, I think this is something that's very promising, given some projects I'm involved in at least on a small scale. I want to say one thing about ideas being unlimited or constant. I just can't resist and then just make a conclusion, which is that one of the aspects is that the very terms that we use to convey ideas often change over time. So if you look at what Dmitry Mendeleev did in developing an entirely new language for chemistry and finding the shortcomings in trying to use only physical terminology to understand something that can only be understood chemically. For example, an element does not have a density, a hardness, a color, an electrical resistance, any of these things. Carbon does not have such characteristics, although carbon compounds do. So you need a new language, a chemical language. The issue about the conservation of energy, for example. When this law was passed, nuclear energy was unknown. So does this law require an amendment to say, okay, energy is conserved, but now there is a new form of energy we must also add to this law? I ask the question, was the law correct in the first place? Did the law change? Did our understanding of it change? Was it correct? Or are all of these laws somewhat provisional? Are these all steps in a process of greater discovery? I ask this sincerely. And then just the last one, which I also want to use to motivate reading a specific work of Vernadsky, is the work that Einstein and Planck did in redefining energy, space, time, and matter. And this is something that Vernadsky takes up in The Study of Life and the New Physics, available on Amazon. It's a good first read. You can see it's not incredibly long. And Vernadsky takes up here explicitly, how has the redefining of these basic terms changed our whole approach to science? So perhaps we can get some discussion groups going on these things and expand our circle of discussion in the future.
Okay, thank you. Helga? I think you're muted.
I also want to express my happiness about this meeting. And it is a funny thing with these rumors. I have heard this rumor about this Italian book in English also. So it seems to develop a geological force all by itself as a rumor. Otherwise, I think it is a very brilliant idea to have such a Vernadsky-LaRouche discussion group on a regular basis. I think it would be a wonderful way of inviting scientists from all continents to participate, and that way, replace the cancel culture with some real ideas exchange. I would just like one comment to what Professor Kowalewski said. and that is that I would like to introduce also not just the question of the function of the brain, but the function of the mind. And, I don't think these two things are identical. I think the brain is sort of the bodily mechanism for the production of all these functions. But the human mind is, in my view, something bigger. And that leads to the question of, that one of the absolute areas of study is the study of creativity per se, which obviously is a crucial question in the whole idea of the noosphere. And, what is it actually what makes human beings creative? And creative is not just some arbitrary new thing, but something which is necessarily leading the mankind a step further in the lawfulness of the universe. So I think this question of the study of, what is a classical composition, what is a fundamental discovery, what is required that more and more human beings develop that quality of genius, because I think genius is, in the final analysis, the only condition of mankind worth of our species character. So I thank you, all of you, and till very next time.
Thank you very much, Helga. Bill Jones, Jason Ross, Professor Sergei Pulinets, Professor Vladimir Voyakov, Professor Nicola Scafetta, and Helga Sepp-LaRouche. I want to thank all of you for your participation in the opening panel of today's conference. We're going to conclude with a comment which our Italian associates wanted emphasized for today's proceedings, both for their presentation and in general. It's from the great and ingenious Marie Curie, who said, "Nothing in life is to be feared. It is only to be understood." Panel 2 is called Physical Economy, Developing the Noosphere, and it will begin in approximately 23 minutes. So for those of you who need to get a drink of water, you can join us back here again shortly. Thank you all.